Oh, just a note, since we're now recording, if you say anything that you want me to remove, just note the time and I will make sure that happens. So don't feel like and I will caution you if I feel like you're headed into a sensitive area, just to say that. Okay, so these are the course modules that we're going to be covering today. Logistics, I think you probably know where your facilities are. If you don't, we have bigger problems that I unfortunately can't help you with. It is asked that you take notes. One of the problems with doing remote classes is that we are actually we're sitting in environments that we've probably been sitting in for close to a year now. And we've developed certain habits of consumption, whether that's checking email or looking at Facebook or whatever it is. And I'm not judging any of that. I think all of that's fine. Do note that if you want to squeeze the max out of this class, you will unfortunately need to focus, which I think is something that's diminished over time and is probably next to time itself is one of our most valuable resources is our focus, because that's what everybody wants from us. They want our attention. They want us to watch their shows. They want us to watch their ads. They want us to spend our focus buying their stuff. So just know that it's a pretty important facet of what we're doing today. So you might see me looking down and to the right. It's because I have my own notebook that I take my own notes on. I highly recommend that you do that either digitally or otherwise, because though you will have the recording and you may actually want to go through it to go some finer points, writing stuff down with your hand, especially if you're filtering what I'm saying, is going to drive retention of this material deeper than probably anything else that we could do, other than having some kind of intense emotional impact against you. But we're not going to do that. So I do recommend that you take notes, try to stay as focused as possible. We will take breaks pretty much every 90 minutes. And just so you're forewarned, at noon, no matter where we're at, we're going to stop. You probably know this, but there's been several studies that have shown that you're really only going to get about maybe 3, 4, maybe if you're lucky, 5 or 6, if you're a really strong focused person, of focus time a day. So I'm going to try and break us up every about 90 minutes or so that we can take a short break, so you can kind of allow your subconscious and everything to digest what we're talking about. And at noon, we're going to take an hour-long break, and you're going to get that space back to just, refresh, get away from your computer, interact, go have some human interaction, maybe get some sunlight. And then at 1 o'clock, we're going to reconvene, and then we will finish out the remaining 3.5 hours. Okay? Any questions about breaks? So basically about an hour and a half, and then at noon, we're definitely going to be taking a break. Okay. All right. So let's get into cloud. Let's get into it. Okay. So we're going to define the cloud versus on-premise, state some benefits of AWS. Note that your mileage may vary about the benefits of AWS. I'll point that out. We're going to talk about the different AWS service categories, describe AWS's physical infrastructure, which might be arguably the most important to this after the business stuff, and then the 3 vehicles by which we interact with AWS. There's actually 3 ways that we interact with AWS, and they actually all lead to one road, which is basically APIs. So whether it's the web interface, the command line, or you're using Python or something like that, we're all interfacing with the API. So we'll talk about that. Everyone ready? We good? Ready to go forward?
Ready.
Okay, awesome. Don't forget, you do have reactions, down on your bar if you just want to give me a thumbs up for an example, right? Good. You don't have to talk. Although, honestly, none of you sounded like introverts, but I've been wrong before. So we'll keep going. All right. So what is the cloud? Well, traditionally the cloud was defined as, it's just other people's servers, right? Because we've had on-premise, which is us hosting our own servers. And even in our houses, we're in a sense hosting our own laptops, our own routers, right? Et cetera, et cetera. Although SaaS is extremely popular. And then, of course, Amazon releases SQS, which is the simple queuing service, and then S3 in 2006. And people are like, well, that's just other people's servers, right? No. The thing that made this different is that this was truly API-driven, software-defined infrastructure that was self-provisioning, right? Self-provisioning, that's actually pretty cool, which means that basically with 15 minutes and a credit card, and it might take a couple hours for things to fully provision, you could be putting servers into AWS immediately. You could be running databases. You could be doing machine learning algorithms. 15 minutes and a credit card. That's all it takes, right? And not only that, but it's not going to break the bank. I run workloads in my demo account, which you're actually going to see here in a bit, all the time. And most of it hits what we call the free tier, because Amazon will give you a certain tier of services for free. They call it the free tier. And if it's a new account, that lasts for a year. So you might have to create another account if you want those benefits to refresh. But there's other services that are free in perpetuity, like 5 gigabytes of S3 storage, right? Or I think it's like 100 read-write units against the DynamoDB table. Like there's all these other services that are just free in perpetuity, no matter how long you have your account, that Amazon just gives you. But this is very different from our traditional on-premise, because wherever the hardware boundaries are, we don't know where the hardware boundaries are. Amazon has thousands of servers in their data centers. And so people are using and giving back and using and giving back all the time to run their business. But we no longer have to wait to provision servers for the 6 to 8 week delivery time that was kind of the barrier before. Now, when we need servers, we just grab them. And when we're done with them, we give them back. If we need them permanently, we can ask AWS to give them to us at a discount. But to date, with notable exception, people have hit AWS's hardware boundary. But for the most part, like you never really see the hardware boundary. Like I've had people ask for 15,000 servers, which of course is ridiculous and requires a special exception from Amazon to even pull off. And Amazon's like, can we spread that across a couple of data centers? Because, you know, there probably is a hardware boundary and they've got other customers to take care of. But the bottom line is that the cloud is software-defined infrastructure, meaning everything in it is driven by an API. So whether it's a virtual machine, a container, an MS SQL database, or object storage, it's all software defined. And so the data you put into it is the only unique thing, or if you start an operating system, which only 2 services do, right? So how does it work? Well, AWS securely and in a performant manner publishes an API that you can create an account for, sign up to, and you can provision what you need. Now, you can go through the console. You can actually use the command line interface, which is called the CLI, or you can actually access the API programmatically using Python, JavaScript, Java, .NET, whatever programming language meets your fancy. Matter of fact, you could hit it through curl commands if you're familiar with Linux, but that's up to you, right? Now, back in 2006, when Amazon first came out, Gartner was like, you know what? People in 2020, established companies, are primarily going to be hybridized, which means that they're going to have on-premise data centers, and they're going to have some of their stuff in cloud and some of it in their data centers. And that hybrid model is the blend of being all in, for example, to AWS or Azure or whatever, versus being all into your data center. That hybrid model is the blend. Now, just to be upfront, 99.9% of the startups that I deal with nowadays, they're all cloud. They don't run physical data centers. Nobody does that anymore. And the only people who do that are established companies and established entities who still run an on-premise data center, or if they're a startup that requires them to have a physical footprint where they need that level of control, that's the 0.1% that I occasionally run into. But for the most part, all the startups that I consult with, that I do volunteer work for, they are 100% all in cloud. That's it. And so in that model, you have no physical footprint other than like end user devices, right? Or end user network. Any questions about those models? Okay. So then what are the benefits? Well, according to AWS, and I'm not saying they're wrong, I just want to make sure that this is from their perspective, right? Is that one, you can stop paying basically for data center investment. And you'd be surprised. I've had like 100-year-old companies come to me and they're like, we want to get completely out of the data center. It's like, really? What? You can do that? Like, I thought maybe legally, like you could do that. They're like, nope, we can do that because Amazon has all the security compliances that we need, right? Now, again, these aren't government contracts, which is a whole different level, right? And then the main reason they want that is they want the elasticity, the flexibility, and the agility that Amazon can provide. Because if you don't have hardware boundaries and you're not having to spend resources managing a data center, then what you can do is you can pay only for what you need, and you can become good at what differentiates your business instead of becoming good at running infrastructure, right? Now, it's a little different for booze because most often booze is consulted for expertise in these kind of infrastructure and kind of like orchestration, DevOpsy kind of like CI/CD pipeline kind of services, especially from an infrastructure standpoint, or from modernizing or deploying applications, right? Or even building applications in a lot of cases. So with AWS, you only pay for what you're consuming. And so businesses really are loving that more and more because they want to get out of the capital large expenditure of having to buy hardware and spend things on like cooling and data center footprint, security, and whatnot. So you can trade capital expense, which is that hardware investment, for variable operating expense. And now notice it says variable because within any given month, if you start new initiatives, your bill with AWS can go up. If you do new initiatives that increase efficiency, it can go way, way down. So it can go in either direction. The other benefit to consider is that there's massive economies of scale. So AWS keeps lowering prices, right? They just keep lowering them again and again and again, because every time that their price per gigabyte or their price per CPU cycle goes down, they pass that on to customers. As they get more efficient at running infrastructure, they lower prices. So like every time they release a new generation of virtual machines, for example, they're typically cheaper and more performant than the prior generation of virtual machines. Now, there are two things that are super hard in cloud in general, from my perspective. Harder, not hardest, not super hard, but harder. One is security, and the other is billing. So billing can be quite a thing with cloud. So just you can benefit from massive economies of scale, but know that understanding the billing ins and outs and kind of costing and whatnot is kind of its own interesting little magic in and of itself. The other thing you can do is you can stop guessing capacity, but you can also guess wrong. So for example, most of us won't know what our application actually runs like once it's in production. And so if your vendor documentation, if it comes back and says, guess what? I need 4 32 processor, 128 gigabyte machines. And you go to run these machines and they're like 10% utilized. And you're like, maybe we didn't need 32 cores. Maybe we didn't need 128 gigs of RAM. How about we downsize these machines to 8-core, 32 gigs of RAM boxes, right? Guess what? You can now stop guessing capacity because you can actually run these systems and then not only vertically downsize them, right, as appropriate, but even more importantly, and probably a better practice, is that now you can horizontally scale in and scale out as you need to. For example, they're like, well, instead of running 32-core, 128 gig systems, what if I just ran a bunch of 8x32s, but I'll give you more of them and we'll distribute the load with a load balancer? So you can horizontally scale your systems with either underestimated or overestimated capacity and actually get it to the right temperature, the right scaling size that you need. And so I disagree with this phrase of like stop guessing capacity. It means you can now correct bad guesses better, right? That's really what the phrase is. Scaling in AWS, particularly when you take state out of the equation for an application and put it on a backend, say like a database or whatnot, really becomes simple inside of AWS. And I would argue is the secret sauce for making virtual machines cost effective on AWS. Without auto scaling in particular, virtual machines it just looks like another data center, right? You can also increase speed and agility because there's no more waiting for a big PO to buy hardware or approval from an IT firm. It's like once you've got all your processes, like your compliance, your security, and your operational processes in place, you can literally spin boxes up that are compliant, fast, and request them and have them provisioned in minutes, if not seconds. The other day, I saw a system boot in 5 seconds on AWS. It was a small T3 small. I was like, did that thing just boot in 5 seconds? I thought there was something wrong with it. I actually restarted it. I was like, huh, that's interesting, right? System just like came up like that, right? So typically know that virtual machines will take minutes, containers will take seconds, serverless can take a few seconds as well, but most of the time it's microseconds. You can stop investing in data centers, which is not a core differentiator for most businesses. Most businesses are not infrastructure service providers. So they actually don't you don't win anything really by gaining efficiencies at running a data center, other than gaining efficiencies at running a data center, which may not be core to your business, but might still be beneficial, but usually isn't directly beneficial to your bottom line. It's one of those ancillary processes that we get good at because we have to. Well, imagine if you don't have to do that anymore. You can stop spending money on personnel and other facets to maintain the data center. You can take those people and put them on other projects that are core to your business instead of having them maintain those data centers. You can go global in minutes, which we'll talk about AWS's kind of like amazing kind of footprint as far as infrastructure here in a second. But sorry, Google decided to talk to me for some reason. Just know that as you can see right there, Virginia, Ohio, North Carolina, Oregon, Mumbai. That's no longer Osaka local, it's just Osaka now. Tokyo, Central, like there's Canada, right? There's a bunch of different like places that these footprints can happen. Me. All right. And then of course in the EU, South America, they've also got a footprint in Africa, Bahrain. So they're all over the globe. So you can go global in minutes. AWS is arguably first and foremost a security company. So be aware that you can keep your data safe, you can meet compliance requirements, save money, scale quickly. That's all absolutely true. AWS really goes to great lengths to make sure that security is the number one thing that's present and happening inside their services. So you'll hear a lot about security implications for fundamental components, but also they have a swath of security services and tools, and they have one of the best security teams that I've ever interacted with, particularly when it comes to distributed denial of service attacks. There are a number of service categories, and you'll see them here. But like if we also go look at the console. Hello, are you signed in? Let's see. Let's go to the console home. So this is actually the service console for AWS, and I'm actually going to blow this up a little bit. I'm actually logged in as an IAM user right now. Ignore the stuff on the right. Those are really just advertisements and learning opportunities. But you'll see here that I've got recently visited services, and then it goes right into build a solution. But if you click all services, you'll see things like compute. There's the quantum computing that I was just talking about. There's a bunch of services here. This can be overwhelming. Everything from storage to media services to front-end web and mobile services to databases, migration, machine learning, business applications. There's a lot here. Here's the thing, just to take this in. You only need to know the services that are relevant for your project. And most of the time, that's going to be maybe 5 to 7 services. It could be 10, depending on what you're working on. But most of the time, it's 5 to 7 services. For example, to deploy a virtual machine, you'll need to know EC2, which is the core virtual machine service. And you'll probably need to know VPCs, which is down in networking, right? And so those are the two things that you'll spend the most time looking at, for example, because you'll need to have a network that your virtual machine can hook into. And by the way, there's usually wizards in each of the services. And then, of course, you'll need to know virtual machines because obviously, you're going to launch a virtual machine. You're going to need to know how to do that. By the way, almost everything in AWS has a wizard that will actually walk you step by step if you use the console and you're learning. But most of the time, when we launch stuff in AWS, objects, resources, we don't use the console. Console is great for learning. It's great for visualization, but it's not really used for scalable deployments because there's an API, right? So we use the command line or we programmatically define our infrastructure either through a declarative file or through a procedure for how we want AWS to build things, right? But know that for now, we're going to be spending time in the console because we want to visualize, we want to learn these concepts. So this is the management console, its entirety. Just know there's a bunch here. Be aware there's a security and identity compliance section that contains all the security, identity, compliance stuff. Here's some cost management. There's the virtual reality service, which is called Sumerian. And then other things like end user computing, IoT, analytics, game development. There's a satellite thing called Ground Station, right? There's a RPA RoboMaker process here as well. So again, just know there's a bunch of fringe services here that we're not going to look at. There's a lot here. It can be overwhelming. Questions about any of that? Did anybody see anything here that surprised them, or do they not see something that they expected to see?
I have no idea what the VR thing is. Wow, that there's even an option for that.
Yeah, it's a little weird, isn't it? Yeah, Sumerian basically allows you to help. It like will host and help you create applications for a virtual reality, augmented reality, right? So it'll actually help you create like 3D immersion environments and host them. Isn't that weird?
Yeah.
I thought it was too, actually. Yeah, that and the fact that they have quantum computing, which by the way has gotten a lot of attention. Oh, and they have blockchain. That's another one that like really throws me for a loop. They have blockchain out here. I don't know where it's currently at. Maybe over here. Here it is. There's the managed blockchain. So if you want to create your own alt cryptocurrency, you can do that on Amazon's services. So yeah, I don't know what to say into that. All right. Any questions about the value proposition or the benefits or just the general kind of buckets that services run inside of AWS? I think I said this before, just want to make sure. We're mainly going to spend our time in compute, security, and networking. Like those will probably be the primary areas. Those are the core services that 90%, if not more, of companies use. Compute, networking, and I would say the database and security services. That probably is covers most of it. Okay. Let's talk about AWS's then global infrastructure, because this is an interesting concept. So Amazon has these like clusters of data centers, but they're actually clusters of clusters. It's like a meta cluster, which is a really weird phrase to use. It's like, well, do we have apples? Well, we've got apples, but then we've got baskets of apples, and then we've got like bundles of baskets of apples. It's like really weird to think about. But Amazon has these data centers, and they've got clusters of them, and then they've got clusters of these clusters. So there's interesting kind of like categorization that happens with Amazon's data centers, which are distributed around the world. So everywhere you see a circle, I think this was as of 2019. These are like the different locations that Amazon publicly runs their data centers. Now, notice that for each circle, it means that in that region, there are a certain number of clusters of data centers, and that number represents the clusters that they have. For example, the 6 that you see kind of on the eastern seaboard of the United States, that's Virginia. So there are 6 clusters of data centers in the Virginia area. We don't know where exactly, although I bet you could find it on Google Maps. I'm sure someone has reported it, right? But basically, there's 6 clusters of data centers that make up the region of Virginia. So just to take this in, if it says 3, that means there's 3 clusters of data centers that make up that particular region. If it says 2, there's 2 clusters of data centers that make up that region. So here, that 4 in the upper left-hand side, by the way, that's Oregon. It's also known as US West 2. It's got a code to it. And US West 2 or Oregon has 4 clusters of data centers that make up that region of Oregon. And you might say, Michael, why do I care? Well, when you run virtual machines, they have to run inside of a region, inside one of these clusters of data centers. These clusters of data centers are called availability zones. Availability zones make up a region. So when you get a cluster of availability zones, that makes up a region, right? So Virginia, for example, has 6 clusters of data centers called availability zones. So it has 6 AZs, 6 availability zones. If we go over to Ireland, which is the one over in Europe in the top left up here, yeah, top left, not right. Although my video seems to be reversed, so bring my fingers. Note that there's 3 availability zones that make up the Ireland region. Where are those data centers? We don't actually know. Amazon doesn't say where their data centers are, right? But we know there's 3 clusters of them, because that's 3 availability zones. So, by the way, the green is planned regions, but it's kind of done. Actually, like this has already been done. Like there's already regions in those data centers. If we actually wanted to get an accurate map of what this actually looked like, what we would do is we go type in AWS region map. And what would happen is you would get their global infrastructure map, and you could see down here an interactive map of all of their stuff, all of their regions. So for example, this is Northern Virginia. Notice it says it has 6 availability zones. Ignore, by the way, the local zones and the wavelength zones. I'm not going to talk about that. That's a complicated topic. But note that there are 6 availability zones right there attached to Northern Virginia. If we go over to Oregon, note that there are 4 availability zones launched. If we go over to South Africa, to Cape Town, notice that there are 3 availability zones, and that was just launched last year, right? So note that when you run a virtual machine, as an example, anything that has a network card in it has to live inside of an availability zone. 2 or more availability zones make up a region. There are services that are regional that run across an entire region across all the availability zones, but a lot of services are specific to an availability zone. Meaning you have to pick not just Virginia, but you have to pick data center 1 in Virginia, or data center 6 in Virginia, or data center 3 in Virginia, and those are availability zones. So when you see these numbers, you know that they're referring to availability zones inside that region. Questions on that? Notice that one of the circles has a 1 on the far right-hand side. That was Osaka, which was a backup for Tokyo back in 2019, 2020. Just so you know, Osaka is now its own data center. It's its own region. So most regions, by the way, have 2 to 3 availability zones. Amazon doesn't run less than 2 availability zones in a region because they require you, best practice, to run your services across 2 availability zones. Let me say that again in case you weren't paying attention. Best practice with Amazon is that if you're going to launch a virtual machine in its production, you need to run 2 virtual machines because you need one in one availability zone and one in the other availability zone. Because if they have a failure, it's going to be along the lines of an availability zone. So you're going to want the other availability zone to be up and handling traffic. So Amazon doesn't run a region with less than 2 availability zones because they want you to run services in 2 zones. Does that mean that they both need to be like supersized? Possibly, depends on what your business continuity requirements are. But typically, they want you to run 2 services or 2 boxes in 2 availability zones to make sure that things are redundant. That's best practice for production workloads. Here, by the way, this is Singapore, which is also known as AP Southeast 1-1. So this is AP-1. If I add a letter on the end of a region code, that's an availability zone. Let me make that incredibly clear, just in case it isn't, right? So for example, up here, this is the name of the region. This is an availability zone in the region because of that little A that's on there. This is an availability zone in that region because of the B on there. You could obviously do the same thing with C, right? Notice that these availability zones right here, this thing is a cluster of data centers. All of these data centers together make up this particular region of Singapore. So when you run services in AWS, you're running them inside of an availability zone or in a region. Very few services are global. Most services are either AZ specific or they're regionally specific. Okay. So if you hear me say things like US East 1, I'm talking about a region. If I say US East 1A, I'm talking about an availability zone. Does that make sense to everybody?
Makes sense to me.
Okay. This is kind of foundational for Amazon's global infrastructure. So when like you'll see it actually when we get to the console. And the great thing is, like, to show you this in action, if I go to the console, I want you to notice on the upper right hand side, notice how it says Ohio. I'm in the region of Ohio. If I want to switch to Oregon, I just click on Oregon, and guess what? I'm now in the region of Oregon, right? Now, if I go in here and I start an EC2 virtual machine, as an example, virtual machines, because they have network cards attached to them, have to run in availability zones. They can't run at a regional level. They have to run in a specific data center, right? And so what I can do is if I come in here and launch an instance, let's say I'm just going to cold launch an instance, and let's just say I just pick the free tier, which is fine. Hello, hello, hello. Once I pick my size and all that other stuff, right? One of the things it's going to ask me is going to say, hey, what VPC and what availability zone are you going to run in? Notice it says US West 2B, US West 2D, 2C, 2A. It's giving me the opportunity to say where I want this virtual machine to live inside Oregon. Which of the data centers do I want it to live in? Now, that's because anything with a network card attached to it, like if you take a Lambda function, like a serverless function, and you attach a network card to it, it has to live inside of an availability zone. Remember, availability zones make up regions. But here's the catch. Let's say that I went over to a regional service like S3. S3 allows me to create a storage bucket that I can just stick files and objects into. Notice that these have what they call home regions. Here's an Oregon home region for this bucket, because S3 is a regional service. S3 is a managed service that has no network cards attached to it that we can see, right? We don't manage those network cards, right? So that makes it so that this service is a regional service that runs across the entire region. And so it's not the same as an availability zone level service. How do you know which is which? Well, you just work with them. But basically the bottom line is if it has a network card attached to it, it's typically an availability zone specific service. Everything else tends to be regional, right? And there are exceptions to that, but they are noted when we go through the services. Okay. So bottom line, regions are made up of availability zones. There are 2 availability zones in every region. Now, why would you choose a specific region? Like, why would that be important? One, are you required to run things in a certain region, like legally, right? 2, is it closer to your customers? 3, are there services available in that region that are not available in other regions? Because that does sometimes happen, very, very rarely. And 4, some of the regions are more expensive than others. For example, it's kind of a running joke that California is going to be more expensive than any other region in the United States. Like somewhere between 20 and 30% more typically. Tokyo is going to be more expensive than Sydney or Shanghai or any of the other kind of like regions inside of AWS in the Asia Pacific section. So like, for example, people typically say like, don't use California unless you have to use California because it's going to be 20 to 30% more expensive. Don't do that. Now, the services availability within a region, that can actually be a real problem. So like sometimes what you need to do is go look at the AWS service availability service map by region. And so if you go and look at the regional services, what will happen is you can actually come here and pick your particular like location. Let's say you're thinking, oh, you know what, what's in Africa? You can actually come in here and see which services are available in Africa. The other thing is that GovCloud used to be in here. Oh, there it is, US East and West. So West was actually built first, East came second. So like if you want to check and see, for example, if Kubernetes is available inside of GovCloud, you can search for Kubernetes, which it is available. If you are wondering if Quantum was available, guess what? It's not available. But if you were like, you know what, I really want to use SageMaker, guess what? SageMaker is right there. Now, there's a bunch of sub-services under SageMaker, so I don't know that everything's available, right? But this regional map, this region table, will allow you to find out which services are available. In general, particularly for GovCloud, 80% of what's available to the public will actually be available in GovCloud. But like the rare things like quantum computing, virtual reality, stuff like that will not be available because they're just super rare. And so Amazon focuses them on either Oregon or Virginia, or where all of the new cutting edge services are launched. So just FYI. So that's another thing that could determine whether you're running a region, but for most of us, that's not a factor unless you're running one of the frame services. Primarily legal requirements, cost, and then proximity to customers are the three primary reasons that we use to figure out whether we need to run in one region versus another region. Most companies run 2 regions. So you typically run more than 2 regions unless they are a global company and need to have focus in the EU and whatnot. So for Booz employees in particular, using GovCloud East and West is a typical pattern that the public follows as well. Most people don't run more than 2 regions. So just so you're aware of that. The reason for that, by the way, is you end up replicating your infrastructure in every single region, and database replication becomes problematic at certain levels of scale. So that's typically why people don't focus on more than 2. So in addition to having regions which are comprised of availability zones, Amazon has another location that's not where they run data centers. It's where they run servers, like cache servers, things like network caching, like for content delivery, or DNS caching. They'll even run some compute functions, like they call it Lambda at Edge, at some of these locations. These are just servers that are co-located with major ISPs that are used to drive content closer to the user. So for example, you'll notice that on the United States and the EU in particular, where there's a lot of major ISPs and tier 1 backbones, Amazon has, a lot of servers in these data centers, so that if you want your content to be closer to your end users, you can actually push video files, JPEGs, HTML, JavaScript, even some API calls close to those servers, so that the user will go to the server instead of going to your source. So for example, if you have a web server in Virginia, somebody's over in California, they'll hit the California Edge server as listed on this map, instead of going all the way to Virginia to get your static HTML content, because that's what caching does, is it takes a copy of your source material and disperses it to all these servers so that users can have a better user experience. So edge locations basically act as cache to improve customer experience. Any questions about any of that?
You said network caching, DNS caching, and is it also file storage? If you had video files and stuff, would those get stored in these locations too?
Yeah, you can actually cache video files as well. So you can do edge streaming from the edge.
Okay.
Yeah. Oddly enough, I actually used this in 2013 to run a video company where people would upload videos and then we get distributed out. And so it takes a copy of the video based on your whatever time to live you specified, puts a copy of it out on the system, and then when the user comes, they actually stream the video from that edge location instead of going all the way back to your origin. So it's actually pretty cool. Content delivery networks, by the way, are definitely not something new. Amazon, Akamai, and Cloudflare, and much of other companies do it, but Amazon has their own version. All right. So that, between the regions, the availability zones that make up the regions, and the edge locations that sit pretty much everywhere there's a major ISP or major metropolitan area, those are the 3 locations, really 2 locations, right, that you can run, is availability zones inside of a region and edge locations, which act as caching locations. A word of note about the edge locations: you do not actually specifically push stuff out to the cache locations. You just say what could be pushed. And when a user comes in and requests an object, Amazon automatically grabs the object and pulls it out to the edge location. So just note that most of the edge locations, you don't run services out there. You just say what services could run out there. and Amazon's management interface will actually like pull the resources out to the edge. Cool. So let's talk about management interfaces. So there's three ways there's three vehicles to manipulate the API of AWS. There's the management console, which you just saw, right? You just saw me messing around with the management console over here because I was like, oh, now I'm global. And then I think at one point I went to EC2, and then I went from a global status to a regional. So this is where I was showing all the region pieces, right? So kind of switched it up a little bit. And so that's the management console. Let's see. No, not that. How about this? This is the CLI. So there's an AWS command that you can get actually that's installable on Windows, Linux, Mac, doesn't matter. You can get it through Brew, Chocolatey, apps, whatever you're using. And for example, if I type in AWS and then the service, which in this case is EC2, and then an action. So let's say I want to describe all the instances that I have. Right now, I don't have any running in EC2 in US East 2, but let's say US East. Do I have any running in US East 1? I don't think I have any EC2 instances running in my demo account. Maybe I should have started that instance. But notice that my command line is actually saying that I'm in US East 2, right? It was actually the region I'm in. That's because I'm running a command line tool called Starship. If you're not familiar with it, Starship is a way to homogenize your prompts. So no matter what OS you're running on, you can actually see the same thing. So this is how you would, like, for example, you could run VPC, actually it's RDS services here. So you could list databases. So that the command line is where you can create, run instances, start them, manipulate everything you can do in the console, in the web interface, you can do on the command line. And so this AWS tool is actually free for everybody to download. You do have to configure it. So just note that if you get that far, you have to run AWS configure. And it's going to ask you for an access key and a secret key, which is like a username and password. It's going to ask you what your default region name is. And then it's going to ask you what format you want. I actually prefer YAML. So like if we get our, there's an interesting set of commands here. All right, let's try this. So if I run that same command that I was running before, I just changed it to YAML. Notice that it's switched formats from the default state that it was in before. So that is the command line. That's the console. I'm not going to show you the programmatic way because that's going to require us to dive into code, which usually melts people's brains, so I don't want to do that. But you can basically run things programmatically inside Python, for example, which is the language I tend to prefer the most. You can actually create like EC2 objects, configure them, and run them out on AWS. You can actually interact using what's called a software development kit. AWS has a great little web page called AWS Tools, if I remember correctly. And the Tools kit has basically everything that you might want for your particular language. So for example, I use Python. So here's all the like toolkits for my different IDEs. Here's getting started. Here's how to build applications. If all of a sudden I'm in love with Go, here's how to like do sample code for Go. So I'll post this in the chat just in case you'd like to have it. But just know that this is like the tools place where you can also get command line tools for different services, things for DevOps and automation. So if you're looking for particular services, but this is the tools to build on AWS. So again, three ways: web console, command line interface, programmatically, all to get to the AWS API. The console we just looked at, I just showed you the CLI, and then I just showed you the SDK, so you kind of saw the variety of like software development kits you can use to extend either your IDE and language into AWS. By the way, even if you don't have an SDK, you can actually just make API calls against AWS. So you don't need a software development kit necessarily to interact with AWS. The software development kit just makes it a whole lot easier instead of you having to write your own objects. So some key takeaways here is that with pay-as-you-go pricing, just know that AWS has got everything from quantum computing to virtual reality to fundamental services like networking, firewalls, cloud compute, Like there are fundamental services available for you as well as advanced services. They do offer a lot of managed services, but also infrastructure as a service. So if you just want to do networking, that's awesome. They've also got a ton of services that are fully managed services bordering on SaaS that will allow you to create databases, machine learning models and whatnot. Remember that there are like two basic locations: availability zones, which are inside of regions, and edge locations, which sit both in regions and outside of regions for major ISPs that you can actually, like, in a sense, host services or your data. So note that almost all data lives inside of a region availability zone combination, or it can be in a cache location, an edge location, if you've enabled caching for that data. And then remember, there's 3 different ways to access AWS. There's the console, there's the command line, and there is SDKs. There's probably, you could say, a 4th way if you just want to raw access the APIs directly. Questions, curiosities, anything anybody wants to give voice to? I realize this might look pretty weird because it looks like I'm drinking out of a Solo cup, but I'm not. Okay. Let's see while I'm transitioning over. Oh, that might be worth stating. So unfortunately, I can't share the slides with you because AWS doesn't allow me to do that. But that being said, you should have gotten an email from Gilmore Global. Gilmore Global would have basically sent you an email that says verify your account, and you'll get access to their like VST bridge, kind of gilmoreglobal.ca, I think is the URL. And it will give you access to the student guides and everything else inside of what you're seeing here. So every single slide that I'm presenting is actually inside your student guide, and there's commentary inside the student guide. So you're going to have AWS's official instructor notes, presentation notes on the presentations that I'm giving. Another thing to mention before we go forward is that you notice that in this little slide right here, before I blow it up, it says Quick Labs 1. So something to note today is that we are actually going to be doing some hands-on labs, and those hands-on labs are going to be at webage.quicklabs.com. I'm going to actually post that link into chat. You ideally would have gotten an email about this already, and probably said to approve your account. If you didn't, just note that you can actually just go straight to webage.quicklabs.com, and you can click forgot password. Usually the password is WAS admin. So WAS admin is typically the password. If not, just click on forget password. It's going to use your Booz Allen Hamilton account to get in there. So just, have it send you a reset to the password. But this is where we're going to be conducting labs today. Now, we don't have 7 labs, unfortunately, but we do have these labs, which is going to be like the simple storage service, building a web server, and we're going to be doing some auditing with Trusted Advisor. Let's see, Jeff, you were asking me what was the name of the CLI tool that I was using. It's just called the AWS CLI. So that's an officially published by AWS tool. Yeah. Oh, Starship. Yeah, so for prompts, wow, sorry, that could have taken me somewhere bad, at least in Atlanta. So Starship is a cross-shell prompt. So I'll pop that into the chat as well. Starship.rs is cross-shell prompts. And by the way, I'm just using the defaults. So I haven't even changed anything. But if you use Terraform or any other kind of infrastructure tools or security tools or repos or whatnot, Starship is written in Rust, if I remember correctly, and that's the prompts you were saying before. back to where we were. All right, so the 6 of you are enrolled. And by the way, I see a couple of you, at least one of you, used your Gmail account. So you're going to need to use your Gmail account to log in, just so you're aware. But the rest of you all used your Booz Allen Hamilton accounts. This is where we're going to be spending our labs today, is at webage.quicklabs.com. So when we get to the lab part, I'm going to walk us through that whole process to make sure that everybody's comfortable. but just know the labs aren't activated just yet, so you can't do them. They will be activated in a moment. But this is where we're going to be spending our lab time today. Does anyone not have the email to activate their Quick Labs account? Okay. Bear with me just one moment because I need to make one little structural change and then we're going to keep on going. Let's see. Desired hot labs. I'm going to make sure that you have the ability to at least have pre-warmed labs, which is actually important to the flow of the class so that you don't have to wait for things to happen. Okay, so let's go back in and take a look. I want to make sure I activate the first lab for us so that by the time I finish talking, we can roll right into a lab. I am going to pre-warm the labs just to make sure that the labs are ready to go. So you don't have to wait for things to build. Okay. Okay, just checking on responses here. Everyone looks good. Okay, so here's what we're going to do is that we are going to get started with the cloud. We're going to talk about how to build infrastructures, how to store data, how to secure data. Let's get started. Okay, so we already took a look at the console. Already saw there were a lot of products. We're mainly going to be inside of compute and networking. We might spend some time in database and security, but this video kind of re-highlights the services that we were looking at earlier. Now, in our cloud journey, right, typically you want to take a workload, set up a foundation project, like a beachhead project. You know, you might even, like, as we were joking earlier, you might like focus on lifting and shifting because that's the easiest way to get into cloud. You don't realize as many benefits, but it's a great way to transform and evolve. And at least you're there at that point in time. You've offloaded some operational concerns. But setting that foundation, like being able to basically retire tech debt and become more and more cloud native so that you can be constantly experimenting and reinventing, that's what we're looking for. But right now, we're just at the beginning of our cloud journey. So then how do we build our infrastructure? Well, first is we're going to talk about familiar things, such as Amazon's EC2. So Amazon EC2 basically is the virtual machine service. Now, don't get me wrong. There is another virtual machine service that really isn't enterprise class. It's really just a VPS service that you could use called Lightsail. But EC2 is the enterprise class service that everyone uses to deploy virtual machines. Lightsail is just for like if you want one server in a kind of a web hosting VPS style. It's not really for production use. So EC2 basically allows you to start a number of instances, and it allows you to put capacity right above customer demand. So you get to be elastic. You get a lot of control because you've got an operating system that you are responsible for patching, but you can also install whatever software you need. It's incredibly flexible because there's a number of different sizes. What kind of sizes? Whatever sizes you need. You want a 2x4? You want a 2x8? You want a 2x16? Meaning 2 processors and 16 gigs of memory? You can get that. I mean, they do t-shirt size things, so it's not like you can just custom create your own like ratio of memory to processor kind of setups inside for EC2. But they offer a like t-shirt size stepping of systems that you can choose from. They've got AMD processors, they've got Intel processors, they've got ARM processors, they've got their own designed Gravitron processors. So there's tons of flexibility. If you need a 24 terabyte system, you can get that. Now it's a hypervisor, right? But you can get a 24 terabyte system with 448 CPUs if you need it. If you want a virtual machine, you want a couple of terabytes of memory, you can get that. The X series will get you that. So just know you can get pretty large boxes dedicated just to you, right? If you want on AWS, there's a lot of flexibility. EC2 is deeply integrated into the Amazon ecosystem. So not only does it run in specific availability zones, but you can auto scale it. You can have it call other functions. You can give it permissions. You can basically take, your servers and make them run like almost like isolated dedicated applications. You get 4 nines of availability. And of course you can, obviously double that, which is best practice, which is to run across one or more EC2 instances across 2 availability zones. Remember, availability zones are those little subdivisions that make up a region. Availability zones are fault tolerant, independent data centers, right? Or clusters of data centers, depending on how you want to talk about it. But they are independent of each other. So they're tightly network connected, but they have their own independent internet connections and power and cooling, right? So that's how they get the 4 nines of availability. Security, because AWS is arguably first and foremost a security company. And then relatively inexpensive. Like, to give you an example, there's this website that people frequently use called ec2instances.info. And it actually just got bought by a company called Vantage, right? So now it's called instances.vantage.sh, right? And what will happen is you can actually come here and search. Let's say that we want to do the T3 series, which is a tiny set of boxes. Tiny, they're not tiny. Sorry. They're like a test series from my perspective. Amazon will tell you can use them in production, but that's really for advanced users. Notice here that if I need a 8 gig system, that's T3 large, that's going to cost me 0.083 cents an hour. So for less than 10 cents an hour, basically $2 and less, basically about $2 a day, I can get access to an 8x2 system, like 2 processors, 8 gigs of RAM. And by the way, this has a 5 gigabit connection to it from a network performance. And I will pay a little bit for storage as well, but like I can get a terabyte of storage for $20 a month. So it's less than $1 a day. So this whole thing would probably be like $2.50 a day if I got a 2x8 system with a terabyte of storage. That's pretty good, actually. 4 nines, enterprise class, right? High bandwidth, fault tolerant. That sounds great. So know that this is cheap, and that's the hourly cost, by the way, which is the second most expensive way that you can actually buy a virtual machine, because you actually can do things like reservations and stuff if you want to. So just know that there are licensing models, which we'll talk about later with AWS. So this is really inexpensive. For less than 10 cents, you can get a 2x8 system an hour, less than 10 cents an hour. Just a word, just to state this, and we'll talk about this again in billing, is that when you use a non-licensed operating system like Ubuntu or Amazon Linux, you get charged per second. If you use a licensed operating system like Red Hat or Windows, you get charged per hour. So notice this is 0.083 cents per hour down here, this lower right-hand side. So that only happens if you're using a licensed Linux operating system. Windows, by the way, is a little bit more because of the Microsoft tax, but not much more. Oh, and by the way, spinning up EC2 virtual machines is super easy, right? Click, 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 you're done. That's not the most scalable way to do it. But if you're using like Terraform or some other provisioner, it can go really fast, like CloudFormation, for example. It'd be super easy, super fast. You just spin up 50 boxes. Now, when you choose the right instances, basically what you're going to do is you're going to follow the vendor documentation, but also based on what the machine is designed for. For example, the C series of systems is actually a compute series of systems. What that means is that it has a 1-to-2 ratio between CPUs and memory. This is the compute series. This is the C series. This is the 5th generation of this series. C5, right? If I change that to a 6, by the way, let's say a C6G, because that's the only one that exists, notice it still maintains that 2-to-1 ratio between memory and virtual CPUs. Because that's what the C series is the C series has that level of ratio between memory and compute. Now, if I change this and I want a general purpose system, let's say the M5, because that would be easier actually to talk about. Notice that this changes from 1 to 4. 1 CPU, 4 gigs of memory. That's the M series, right? This is the 5th generation. There is a 6th generation called the 6G series. Notice it still maintains the 1-to-4 relationship. So M is for general purpose or median. C is for compute, and that changes the ratio of memory to processor. Okay. If I switch over to the R series, let's say, is there an R5? Yeah. So the R5, notice it goes from 1 to 8. 1 processor, 8 gigs of memory, because the R series stands for RAM. I don't even know if there is actually. Oh yeah, there is. They just released, I guess, the 6G series. Notice that this maintains the 1 to 8 ratio. 1 to 8, 1 to 8, 1 to 8. Notice here, by the way, that there's an RG6G large. That's a 2x16. Notice the extra large is a 4x32. Notice the 2 extra large is double this extra large. The 4x large is 4 times. The 8 is 8 times. The 12 is 12 times. I know you get the picture. I just want to make sure. Right? There's a 16x large down here, which is 16 times. So notice that the t-shirt sizes, the next size up is usually double of the preceding size. So a medium, when it goes to a large, this doubles. A large, when it goes to an extra large, that doubles. So Amazon's pretty consistent with their math. As you get larger with your instance sizes, it also means that your network bandwidth typically goes up. But I just want to say, even the very first systems that we were looking at, the test systems, 5 gigabits is a lot of bandwidth to be shoving through a system. Like, that's a lot of bandwidth. If we go to these larger boxes that we were just looking at, like the R6G, 25 gigabits is a lot of data to be running through a system. So just know also that network bandwidth goes up. By the way, look at the cost of that. That's $3.22 an hour without storage. Probably with storage, it would probably go up to about $4 an hour, right? Note that per day, right? Do the math, 4 times 24, right? We're looking at $96 a day for a box that's half a terabyte of RAM and 64 CPUs. So multiply that times 30 or 31 days, and you start to get a sense of like this box will probably cost you what, $3,000 a month, give or take. But it's one of the largest boxes you can get on Amazon. That's if you really needed that. Okay. Amazon, by the way, uses Intel Xeon processors. They use ARM processors. Which are also Intel. They also use AMD processors. They design their own processors, right? So you want to think about core count, memory size, the storage footprint. Mainly it's memory and core count that most people care about, because you can add storage at whatever characteristics that you need. Sometimes networking is a consideration, but most of the time it's not, honestly, a consideration. Most people are not shoving typically 5 gigabits across their backplane. Know, by the way, that you can get a larger size, and then later, if you can take an outage, or if you have multiple redundant systems, you can downsize those systems. So that was kind of like the stop guessing capacity thing that we were talking about earlier. Just know that that is a facet of what you can do. Hold on. All right. Okay. If you need specific Intel processors, just note that, like, this is talking about the C5 and C4. Notice that C6 isn't listed here. These are the compute optimized instances. Here's the general purpose instances, which is the T series and the M series. Memory optimized, which is R and X's, and then of course the storage optimized, which is actually the HIs and Ds. You won't necessarily need to remember the generation number, but it is asked typically that you memorize that C is compute, M is median, R is high memory, HI and D are disk optimized systems, basically storage optimized. T is for general purpose, but mainly for testing, right? So just know you won't be asked to memorize any or all of this. Just know that there are features here for Intel processors if you actually need them. Note that, as I said before, the latest generation of instances is going to have a better performance to price ratio. So try and stay with like the C6s if you can. They're going to perform better than the C5s, and they're going to be cheaper. The C5s are going to perform better than the C4s, and they're going to be cheaper. So you want to be able to use these new generations of instances. So you want to be able to programmatically destroy and spin up your boxes when you can. Notice that was the C5, which is the compute instance. The M5 is the median or general purpose instances. Notice the 4:1 memory ratio, which is what I was talking about before. Notice that they skipped the R5s and R6s, which are the RAM series. They also skipped the H, the I's, and the D's, which are the storage series of boxes. So just if you memorize those kind of like core 6, C's are for compute, M and T's are general purpose, R is for RAM, and then H, I, and D is for storage optimizations, then you're going to be pretty good. Now, the first question it asks you, as you saw when I was over here messing with the console, and I said, hey, I'd like to start an EC2 instance. And I clicked on launch instance. The very first question it's going to ask you is it's going to say, what's your operating system? You want to, by the way, I used to get away and say they only run Windows and Linux. They also run Windows, Linux, and Mac. So you want to choose your operating system, and which, by the way, you might notice that there's some variations out here as far as like, is this ARM or is it just standard x86 64? Those are pretty much the two flavors they run. Is this an ARM or x86 64? Do note the latest generations of systems actually use ARM. So if you want to get to the T4s or the C6s or any of the latest generation of the Gs, you have to run an ARM processor. Do note that most people don't do that unless they've converted their stuff over to ARM. Most of us, when we launch instances and we choose our operating systems, oops, that's not what I wanted. We're actually going to choose to launch x86 because that's what most of our stuff is running as, is x86. Notice that, why is it, that's not the current generation. T3 is the current generation. Anyway, then after you answer the operating system question, it's going to ask you to size your box. Notice that it's going to show you the boxes that you can look at. Like it's going to show you the sizes of them. You can go to previous generation, but if it's under current generation, that means that Amazon considers these to be current generation systems. Notice that most storage is EBS only, which EBS is the hard drive storage system inside of AWS. And if it says yes to EBS optimized, which most of them say yes nowadays, it means it has dedicated bandwidth to run that hard drive. So if it says EBS optimized, it has dedicated bandwidth on the box just for running this network storage, which all of the systems run network storage. Notice also the IPv6 support is listed over here as well. Pretty much all of the current generations of systems support IPv6. But there's a lot of like sizes here. So you could actually sort, by virtual CPU and say, look, I only want 2x4 boxes, right? Or 2x1.5 boxes. So just note, I think ec2instances.info, which is the website that we were looking at earlier, is better because you can actually sort against all the systems. But when you launch an instance, it will give you the option of also choosing the size of box you want. Questions? Curiosities? Does that make sense?
What kind of application could you run on a box with 1 CPU and half a gig of RAM?
Well, notice that this is the T series, just proof of concept. Or like a Bastion host. Like if you were running a Bastion box, actually, you'd be shocked what can run on half a gig of RAM and 1 virtual CPU. Plus, these things are burstable systems, so they're not meant to run 24/7. They're meant to run and then idle and run and then idle. So they make it good for sporadic workloads, but you're right, for the most part, these are test boxes. Right? That's what the T series is really for. Amazon would shoot me to say that, but like that's what they really are, test boxes. And don't get me wrong, you can get sizable ones. Like this is a 2x8 from the T series, right? Even the T2 series, by the way, up here has large boxes, but the T series is really for testing. All right. Other questions? Okay. Note that once you choose your operating system, you could actually make your own copies of these operating systems. You can upload your own operating systems, and you can actually get stuff from vendors called the AWS Marketplace. So if we go back to my little provisioning setup from before, we can actually go to what's called the marketplace, and we can find Checkpoint, Juniper, like there's like everybody's out here. There's so much out here in the marketplace. These are vendor provided solutions. You can also go and look at the community AMIs, which I highly recommend that you never do, even if it's your own account. Don't use somebody's weird image that's out here in the community. You have no idea what this is from. Now, this looks like an official Windows Server image, and this looks like official Ubuntu, which it is, right? So you can find official vendor images out here. But just to say, under Quick Start, you can also find Red Hat. You can also find Ubuntu. You can also find Windows images. I would just use the official images when possible. Don't use things from the community, and make sure that you're careful about running stuff from the marketplace, because there's no security issue here. These are all vendor official images, but sometimes they come with hidden price tags. So just something to be mindful of. Okay. All right, so you chose your operating system, and then after that, you answer a bunch of questions. Just to go back to that, you answer a bunch of questions about sizing. Then you're going to answer questions about security. You're going to answer questions about networking, and then you're going to kick off your instance. And it's just that simple. So that's how you start an EC2 instance. It's just pretty straightforward. You can add tags, by the way. Obviously, you can configure disks and storage as well. But you can add custom tags if you want. If you want to make sure it says like this is for production, or Michael Forrester is the owner of this box. Here's his phone number, right? If you have a problem. And then once you review and launch, it'll ask you the final question, which is, what key pair or key do you want to use to log into these systems? One thing to be aware of is that Amazon does not allow password logins by default. You have to download a key pair where there's a public and a private key. You get the private key, and on the SSH command line, you have to specify that key to log into your systems. The other thing to be aware of is that by default, you actually have to log in as an Ubuntu or an EC2- user. You can't log in as root into these systems either. Amazon does not allow that. You can change it, but you change it at your discretion. Amazon doesn't start out with that as the default. Okay. All right, so let's do a little quiz here. So Amazon likes to test our knowledge. And you can type this in the chat if you want as well. What are the benefits of using EC2 instances compared to physical servers in the data center? So which of these makes sense? Resizability, the ability to hot add additional RAM, automated backups, paying only for the capacity you use, or the ability to have different storage requirements? Which of these apply? Well, first, all of them. One, can we resize virtual machines? Yes or no?
Yeah.
Definitely. Can we hot add additional RAM to a running machine?
Yes.
You know what? I wish we could. We can't, unfortunately. We could back when we were running Big Iron, but with virtual machines, you can't most operating systems will not allow you to hot add memory or hot add CPUs. So you can't do that one. So B is not in play. C is kind of a trick question because you can create automated backups, but they're not automatic. There's actually a tool called AWS Backup that you can actually create automated backups, but you have to go do it. It doesn't do it for you. D, what? Go ahead. Sorry, there was a comment question.
One automatic, but not two automatics.
Right. One automated, yes. Automatic, no. Yeah. And then pay only for the capacity you use. Well, I've been talking about that all morning, so that's definitely true. And then the ability to have different storage requirements. Well, that's an interesting question for them to pose here because we haven't really even talked about storage. But as you saw, we can create whatever measure or characteristics of storage that we want to using EBS, which is the Elastic Block Store, the hard drive service for EC2. So you can actually have different storage requirements. So the answer here is that yes, the ability to hot add RAM is a no. Automated backups is a no. Everything else is a yes. We can resize. You can give back a virtual machine the minute you're done with it, or the second for that matter. And you can have lots of different storage requirements for your EC2 instances. They have like 4 major varieties of hard drives that you can use inside of Amazon. Okay, so this would be a good point for us to stop and take a 10-minute break. Let's round that up to 13 minutes. So it's 10:02 right now. Does anyone have any questions before we take a break? Okay, so let's come back at 10:15 and we will resume class. We'll talk about where we can store our data inside of AWS. Okay, so I'll see you in about 13 minutes. All right. We are back.
Do you?
All right. So, did anyone have any questions about anything that we've covered this far? Anything about infrastructure, regions, about virtual machine instances? Okay. All right. Let's talk about storing data then, which kind of dovetails nicely with virtual machines. Okay. So, we danced around it before. Here we're going to talk about it. So, Elastic Block Store is basically Amazon's virtual hard drive service. It is persistent block storage for virtual machines, so it doesn't work outside of EC2. It can be attached to hosts like EC2 virtual machines and to containers. So it actually can be a virtual hard drive service for containers as well. It is protected through triple replication, so typically within an availability zone. Because just so you know, EBS hard drives are locked into a particular availability zone unless you snapshot them out to the region, but they have to be, they run inside of an availability zone because EC2 virtual machines run inside of an availability zone. But there are 3 copies of any of your data when you put it into the EBS system. And so if one copy fails, the other 2 copies will take over. So it's protected through replication. There are 4 different drive types. There's 2 solid state drives and 2 mechanical hard drives. The fastest one, but also the most expensive one, is called provisioned IOPS, also known as IO2. So don't let this slide fool you. It says IO1. There's now an IO2. And then there's a general purpose SSD, which is what 99% of people run. Is they run with what's called GP2, GP3 is now the new version, right? And so they run GP3, which is the new general purpose SSD drives. These are solid state drives. They're basically like memory on disk. And they are super fast, and they account for like the vast majority of all use cases for hard drive need inside of AWS. If you need cheaper storage that's more infrequently accessed, a little colder, and you don't mind it being slower in a lot of use cases, then the mechanical hard drives, which is known as SC1 and ST1 respectively, are the cold hard drives, which is what SC1 is, and the kind of throughput optimized mechanical drive, which is ST1. But these are slower from an IO perspective compared to general purpose and provisioned IOPS. So there are those 4 different drive types. Most people, when in doubt, use the general purpose SSD, known as GP3 now, has the like hard drive that they're going to use. If you need colder storage, you'll look at the other 2s. If you need faster storage or you need more consistent throughput, like if you need more than 16,000, 32,000 IOPS a second, which I just want to mention is a lot of IOPS, then you can look at the provisioned IOPS where you get to turn the dial on the number of IOPS the drive has. They're actually coming out with a new version called Block Express, which is 256,000 IOPS, which is input and output operations per second, read writes on a system. And by the way, that's like in ridiculously fast, way faster than most enterprise systems I've ever seen. But again, most people just fall back to GP3, general purpose, if they need hard drive. You can expand or even contract a hard drive. Note that you do have to deal with your operating system around that. Scaling out is easy for an operating system. Scaling in can sometimes be a challenge depending on the file system that's been put on the drive. But you can scale storage up and down. You can even change types of storage in some cases really easily. So it's really easy actually to manage and navigate. You pay only for what you've asked for. So if you ask for a terabyte, even if you're not using a terabyte, like you might ask for a terabyte and only use half of it, you're still going to pay for a terabyte, just so we're clear. You pay for what you've asked for what you've provisioned in this case, not necessarily what you're using. And most other services, it's what you're using. But in all cases, it's always what you provision. If you ask for a 2x8 system and you're only using it 50%, you're still going to pay 100% for a 2x8 system. So it really is typically what you provision. You can also snapshot your hard drives. So you can snapshot them easily, either manually or you can create a lifecycle policy that snapshots them automatically. But in all cases, you have to like create it yourself. Snapshots, by the way, are encrypted if the hard drive's encrypted. So you can encrypt a hard drive at hard drive creation time. You can also convert a hard drive to encrypt it and reattach it to a system. I don't think you can encrypt in place. At least I haven't seen that. So if the hard drive didn't start out encrypted, you're going to have to create a new copy of it that's encrypted before and replace it. I don't think you can encrypt a drive in place. Now, don't get me wrong. Inside the operating system, if you want to encrypt the file system, you can. But this is about how the data is stored on AWS. It's encrypted. Now, EBS is the hard drive service. That is directly attaches a hard drive to an EC2 virtual machine. S3 is a different beast. S3 is a managed storage service. It also stands for the simple storage service. And this is where you just put objects, almost like a Google Drive or a Dropbox, but more enterprise class, faster, whatnot. And you put objects out there under these like folders called buckets. Bucket is the highest level of storage you can get in S3, and you put objects underneath a bucket in S3. The data is 11 nines of durability, but only 4 nines of availability, typically. That means it would take Amazon like 1,000 years to lose one of your like 10,000 files. So I don't know that I've ever lost any data on S3 unless I've deleted it on accident. You are limited to the size of a single file or object being 5 terabytes, but I got to tell you, that's usually larger than most of us even deal with. So that's fine. It is technically, from Amazon marketing standpoint, it is technically unlimited storage. So you can actually provision as much storage as you want out there for S3. S3 basically is key-based, which means that you put a file out there, it gets a key, and that key, by the way, is typically the file name. Just so we're upfront about it, the file name is typically the key, including any folder prefixes, and then you go and request it, and then it gets returned to you. So you either push the file or you pull the file in its entirety from S3. This is not a mountable system. You do not mount this as a disk drive on your operating system. It's more like you are accessing a remote storage system and you're pulling files in and out of it using APIs. It's not a file system. Most people use S3 as their default way of storing large number of files, log files, video files, web-enabled files, JavaScript, CSS, HTML. You can even run a static website on top of S3, like natively. Like you can get a domain name and attach it to the S3 bucket. So S3 is really great for hosting large numbers of files that you either want to access concurrently or you want to share out with the world. Every file that you stick in S3 gets a URL. Not everybody can see or touch that URL unless you unclick about 3 things to let it be publicly available. So all those people you read about in the news who made their S3 information available on Amazon's S3, 100% their fault, because Amazon bends over backwards to make sure that you know that you're about to share things publicly with the world. Do you really want to do that? That really is on us as the customers if we say yes to that. But it's not just a storage bucket. It's got versioning. It can do lifecycle management. So like if a file like is older than 30 days, you can actually step your object or file down to what they call colder classes of storage, which means cheaper, but also slower. You can make it so that if someone pulls a bunch of files off your bucket, they have to pay for it, right? Which does require them to have an AWS account. So S3 has a lot of uses, and it's probably like one of the most frequently used services inside of Amazon, just because it's a great way to store large numbers of files. Now, S3 has a colder cousin called Glacier, no pun intended. And this is the archival and backup service. This is the compliance and archival service inside of AWS from a storage perspective. So it's S3's like colder cousin. And there's actually a version called Deep Archive. So Glacier, and there's Glacier Deep Archive. Glacier is typically, in my experience, guesstimating about 1/6 of the cost of standard hot and fast S3 storage. But you actually don't have access to the objects. You have to request that the objects be restored back to S3 and then you can access the object. So this is really for archival storage. And you can create lifecycle policies that say, look, I stuck it in S3 because I wanted to share it out. And then after 30 days, I want you to step it down the glacier. And then after a couple of years, I want you to delete it. Here's an example, by the way, in the console. If we go take a look at S3, not S4, I don't know what S4 would be. But if we go take a look at S3, you'll see that I have a couple of buckets out here. Now I have one called BAH admins. I don't even know if BAH admins actually has something in it. Let's go take a look. Oh yeah. So different classes that I've taught for Booz Allen, including some templates and stuff, simple greeting files. So in here is a document. Notice that in here is some presentations in collateral, or like a Jenkins file, some migrations files, whatnot. This object, this zip file, actually has a URL attached to it. Now, if I put that URL in a browser, it's actually going to ask me to download the file because it's shared out, right? I don't know if this is publicly available. Let's go take a look and see. Are you publicly available? There's no object lock, no metadata. Let's go ahead and look at the permissions. So basically anybody in the world can read, and notice that it says, hey, by the way, red alert, everything, this whole thing is readable. This is publicly accessible, right? So anybody can access this. It's available to anybody. So if I post this link into chat, everybody would have access to it, which doesn't matter. It's Booz Allen content anyway, so it doesn't make a difference. If I had turned on versioning, there would be different versions enabled here. Like every time I changed a file, it would actually create a copy of it. So I would have different versions so I could roll back or forward if I needed to. But note that every file I stick out here could end up being publicly available if I've set my permissions to be publicly available. Notice that the top level bucket here is called BAH admins. That's the biggest deployment aspect of S3. Anything put under that bucket is actually in that bucket and adheres to the permissions of that bucket. Notice it says here that access wise, anything in here could be public. Doesn't mean that it is public.
Is there a name for the I'll call them folders for now, underneath the bucket?
Yeah, so they're officially called prefixes because they're actually attached to an object. It looks like a file system, but it's really not. So like, for example, for the one that we were just looking at, which was that under docs? Yeah, here it was. Oddly enough, the full path to this object is docs BAH presentations, right? So if we go look at the URL for the object, you'll notice that it says docs right here.
Mm-hmm.
Has the bucket name right here, because that's the full path to the object. So that's actually called a folder, but it's actually technically a prefix.
And you can have an arbitrary number of levels of prefixes, I assume, before an object.
Oddly enough, it works just like a file system. I could put 20 prefixes, 20 folders in front of that if we wanted to. So it could be like docs, 2020 / Booz Allen / class name / Michael Forrester. Like we could just keep on going. I don't know that I've run into a limit with the links yet. I'm sure there is one.
And how is access control managed? Is it just through email or?
So we're using the console. You could obviously use the CLI or SDKs to do that, but the bucket has permissions on it. Notice that I have enabled it so that it is allowing public access.
Okay.
So this is on by default. By default in AWS, every service you start, no one has access to it. Everyone. Doesn't matter if it's EC2, a database, nobody has access to it. So I had to come in here and actually disable this because I was actually sharing it with students, right? In addition, once you actually enable the possibility of public access, you then actually have to come in and grant access. So notice that in general, I don't have, I'm the owner of the bucket, right? So the owner of the bucket has read, write, and can listen, write objects, but nobody else does. So permissions are actually managed inside the permissions section of the bucket. Now, I just said that. If I come in here, I can actually override the bucket's permissions by coming in here, looking at docs, looking at the collateral. And if you come down here and look at the permissions for this one, right? Notice that there's no object lock or whatever. But notice that this, sorry, I'm on the wrong tab. Notice that this particular object, the zip file that I was just looking at, it has read and read-write object for the owner, but then it has something odd that the bucket doesn't have, is that it's granting read access to everybody. So permissions are controlled by the bucket and also by the object itself. So the object can actually have different permissions than the bucket has. You can force it, by the way, to always adhere to the bucket's permissions. But I don't like to open everything up to the world. I like to open up specific things to the world, if that makes any sense.
Okay. But I mean, as far as user, so if you wanted to control it through a group of users, essentially they would actually have to have AWS accounts.
Or if you're federated with, Active Directory or Okta or Ping federated, you can federate to another system.
Okay, all right.
Yeah, and you could force them to be authenticated with Google or Facebook or whatnot. So there's a whole section of AWS called IAM, which is Identity Access Management. Identity Access Management can be federated with anything that supports OIDC or SAML.
Okay, all right.
Yeah, cool. which is pretty much everybody. Like ForgeRock, all the guys, they all support OIDC2 and SAML. Okay. So, yeah. And the way that works is that when you federate, you actually get a temporary role assigned to the federated ID. And then that role is an AWS role, and that has permissions attached to it. Okay. So you can even control their permissions, even coming from a federated system.
Okay.
Yeah. So.
Thank you.
Yeah, and what you do here is that when you came here, you would actually specify the particular group that was authenticated. So you could add a grantee if you wanted to. Here. Okay. Cool. So that's S3. I just wanted you to see that because they don't really get into the like permissions and all those other pieces about how S3 functions. But Glacier sits behind S3. And so when you roll an object from S3 into Glacier, it disappears from S3. It's listed in Glacier, don't get me wrong. And it's in some cases, it's even listed inside of S3 as being in Glacier, but the object's not actually there, it's just a pointer. And then if you need to retrieve it, you go to Glacier and say, hey, I need to retrieve this. In about 3 to 5 hours, it starts the restore process. And then it will kick it back into S3 and it'll show up as an object that you can use. Objects inside the same bucket can actually be at different tiers of storage. So like within that BAH admins bucket that we just saw, I could actually have something in Glacier, something in S3, something in S3 infrequent access, something in another layer of S3, because S3, just so you know, has about 7 different layers of storage, classes of storage that you could go into. But Glacier is the coldest and the cheapest as a result. You can also put object locks on Glacier and S3. So if you're into security and you're like, look, I need to make it so that people can read this, but no one can touch it. No one can change it for any reason. You can put immutable locks on your files so that nobody can change the file in question. You can actually set those to be indefinite, which can only be undone by a long conversation with AWS, or you can make them time retention and say, look, lock it for a year and then unlock it afterwards. Glacier is great for anything that you need to just put away and retain, and you don't mind if you have to wait a couple hours to get access to it, right? It can act as a tape drive. It can, legal compliance, any kind of preservation, right? Glacier is a great subclass of S3. We already talked about vault locks. Here, by the way, are all the different storage classes. I'm sorry, vault locks were the object locks that we were talking about before, right? The ability to lock an object so that nobody can read it or change it, right? S3, these are the different storage classes. Notice that in this particular diagram, they go from hot, super fast storage, and as they step down, it gets colder. The only exception to that kind of performance thing is intelligent tiering. Intelligent tiering is not really in and of itself a class of storage. What that does is that if you say I want to intelligent tier my S3 objects, what it will do is it turns on this machine learning algorithm that basically figures out the access pattern for your objects, and it will move it to cold storage if the object isn't used, and move it to hotter storage if the object is used. So intelligent tiering is a little different because it sits a little outside the different storage classes. Its main job is to put your object in the right storage classification based on how heavily it's used. So, and then they've got infrequent access, one zone infrequent access, which is less redundant, S3 Glacier, which we just talked about, and then Deep Dive, also known as Deep Archive, which is the coldest class of storage. Each of these, by the way, has a time interval associated with them. For example, if you go into infrequent access, it needs to stay in infrequent access for 30 days. If you go into Glacier Deep Dive, it needs to stay in the Glacier Deep Dive for 6 months. If you pull it out early, you pay a little extra fee for that. So make sure that you understand what the different storage classes are before you decide to use them. Cool. Questions? Comments?
Do any of the other classes of storage other than the standard infrequent access have retrieval fees?
Sorry, I missed that very last thing that you said. Have what?
Retrieval fees?
Oh, no. Yeah, Glacier and Glacier Deep Dive will have let me rephrase that. They all have retrieval fees if you violate their rules. So, for example, infrequent access needs to sit there for 30 days. If you pull it out on day 29, you pay a retrieval fee. Glacier will take 3 to 5 hours to start a backup. If you want it to run in 60 seconds to start a backup, you have to pay an expedited retrieval fee. So you don't pay retrieval fees unless you violate their rules. If you violate their kind of like rules, then they're gonna charge you a retrieval fee. Yeah. So it gets tricksy, to borrow a Lord of the Rings term from Gollum. It gets tricksy, right? Because if you start using a bunch of different classes of storage, you're gonna need to learn a little bit about the rules to navigate it well. By the way, the fees are relatively cheap. It's when you start violating them 1,000 times, which probably means you're using the wrong class of storage, that things get weird. Most of the time, unless you just made a bad decision, you don't habitually use storage incorrectly. You just like, oh, I forgot that wasn't supposed to go into archive. Let's pull that out. That's not supposed to be there. Okay, here's an architecture where you got an internet gateway, a web application, and we are now putting data into an EBS volume, database data, because we don't want to actually reuse. Just so you know, sometimes EC2 virtual machines come with what they call instant storage, which is like a local disk on the actual like host virtual machine. You don't really want to use that. If you ever see, like we saw this earlier when we were actually poking around in EC2 instances.info. Notice that some of these, let's pick a good one. Notice that some of these have what they call instant storage. See the 75 gigabytes of NVMe SSD? That's like super fast, by the way. NVMe RAM, disks are super fast. Here's the problem. This storage, this instant storage, is only alive as long as this virtual machine is attached to that host. Here's the problem. If that machine crashes or you reboot the machine, you stop it and start it, not reboot it, stop it and start it, it's going to go to a different physical host. And when it goes to a different physical host, you're going to lose that storage. It means anything that's on there is gone. So instant storage is great for like temporary files that you can easily recreate, but don't be fooled. Best practice is to not use instant storage that is attached kind of for free to some of these instances, because you will lose that data if that system crashes. It will be gone and you cannot recover it. You can't write Amazon and say, hey, can I get this back? Amazon cannot get it back for you either, right? So in our architecture that we've got here in our example, they're emphasizing that we're not going to use the instant storage and we're actually moving everything over to these EBS volumes, because by doing so, we're actually enabling more persistence and possibly better performance in the long run by using EBS volumes instead of using instant storage. I've kind of talked to Amazon like, hey, can you just remove instant storage? You've had it for 10 years. It's a big gotcha. People fall into the trap all the time and then they lose all their data. And they're like, yeah, we're working on it. So it's a direction they're going in. And then S3, by the way, would allow us to actually put all of our static web content. So if we want to take everything that's not dynamic off of the web server and stick it in an S3 bucket, we can then offload our JS, our CSS files, our style sheets, and stuff like that all of our HTML, all of our JavaScript could actually live on the S3 bucket, and then we could run either smaller web servers or have more users per web server, because they're no longer just feeding out static content, which is what S3 is really designed for. S3 is perfect at hosting basically web-enabled files. And then, by the way, there's an internet gateway there, because every AWS account, VPC, a virtual private cloud, comes with a internet gateway that gives you, like, I want to say it's like terabits of connectivity to the internet. It's just ridiculous. You usually don't manage internet gateways other than just to know that they're there. They are virtual devices. They are managed by Amazon. They will route you, not NAT. Let me make sure I'm clear on that. They will route you to the internet. They will not NAT you to the internet. So if you enable your virtual machine to be on the internet gateway acts as a router for you to get to the internet, but it's not a NAT. It's not like your home network. It's a direct connection to the internet. There are tons of firewalls, by the way, here in place naturally. So don't take that as a vulnerability statement. There are tons of security measures here to make sure that even if you're exposed to the internet, no one's going to be able to do anything with you. Like I said before, Amazon, first and foremost, is a security company from my perspective. Speaking of which, let's talk about security. But were there any questions about EBS, S3, or just in general, any questions around those two storage services? Okay. Just to check in, are we headed in the right direction? Are people learning? Is there anyone who's not learning anything? You're like, I've learned nothing, Michael. We need to talk. Okay. Good. Because if you're not learning anything, then we definitely have to talk, because I don't want to waste your time. All right. Good. Excellent. All right, we'll keep going. We're going to do this last little section, and then we're going to roll right into a lab. And then we're going to do one more section before lunch, and then we're going to be at lunch. This, it's here. Time is moving. Okay. So let's talk about this. So in this picture, we've got our region. Let's say it's Virginia, just to make it easy. And then we've created a virtual private cloud, which a virtual private cloud is just like a network segment that you can create usually a maximum of 5. You can actually add more if you want, but 5 is usually the default max, and it's got a range to it. So it's got like networking information attached. And then what we do is that inside that virtual private cloud, that VPC, that big green box that's around there, we then create subnets. And the subnet networks are just like our home networks. We've got a home network right now that I'm sitting on. Mine's like a 192 something, that I am streaming across that network through the internet to a centralized server, and the rest of you are hooked up to that server, and you've got your own home networks. And so we've all got like these home networks, these subnets, if you will, that we're sitting on. Well, you create subnets also in AWS, and the subnet can be a private subnet, which means it cannot directly route out to the internet because it doesn't have like basically the right IP address scheme, which is the way most of us run our houses. We actually are running private subnets, and we have a device like a cable modem or a router that actually NATs us out. It translates us out to the internet. But most of us are on private subnets, but public subnets are actually a part of the internet. They have an IP address and schema that allows them to participate with the internet, and the internet can participate with them if the firewalls allow it. So a public subnet has direct access to the internet, and a private subnet has indirect access to the internet. And that's a two-way street, right? So if you allow it, that means you can have indirect access into your private subnets, which typically doesn't happen. But remember, if you're on a public subnet, the internet could get to you if your firewalls allow it. With a private subnet, there's no route. With a private subnet, the internet cannot even really get to you at all without a proxy. So we've got private and public subnets that are sitting in an availability zone inside of a VPC, inside of a region. Notice there's a couple of different layers here, right? Now,
Michael?
Yes.
I'm confused why the availability zone is depicted within the VPC and not the other way around. Can you explain that?
Yeah, so the VPC is a regional construct, and the availability zone subnets are availability zone constructs. So oddly enough, availability zones sit inside of a VPC because the VPC is a representation of the region to a certain degree. So when you create a subnet, which is a network chunk, network chunks cannot span across data centers. They have to sit within a single data center, which is why subnets sit on or in a availability zone, but VPCs span the entire region. So virtual private clouds are like the big pie, and the subnets are the slices of the pie. Right?
Yeah. Okay. I think I see how it works. Thanks.
Yeah. And there's more pictures, so it'll make more sense. Now notice here with your public subnet, we're connected to the internet, and with the private subnets, we're connecting to a data center. That doesn't always have to be true, by the way. You can't actually connect private subnets indirectly up to the public internet. You can also connect public subnets up to your corporate data center, but that's the typical way it's done. Here, by the way, we're in the overall VPC, and we've got a bunch of subnets. Those subnets are sitting inside of an availability zone inside the VPC. And naturally, every single EC2 virtual machine that you run has a firewall around it. They're called security groups. Security groups cannot be removed from an EC2 instance. They are always attached to an instance. So every single virtual machine has one or more security groups around it. Note that in this particular section right here, this security group over in this area, actually, let me use a different color and maybe use something else here. In this security group right here, security group A, what we've got is it basically says that for this is security group A on the left-hand side, that any traffic that's on port 80 or port 443 can actually get to these instances, and they can respond to it. So they can receive initiated traffic, and they can respond to the traffic as well as it comes in, because these are stateful firewalls, meaning they will allow you to respond to initiated traffic without having another rule in place. Now notice here that with the security group B, they will only allow port 22 connectivity from the corporate network, which is what this 10 addresses. And then security group C down here will allow any traffic as long as it comes from security group B. So C will allow any traffic from B to get to it. But B will only allow traffic from the corporate network. These security groups, by the way, are all stateful firewalls. That's what security groups are. They're stateful firewalls. Now removing all my messy drawings. These kind of CIDR notations, classless internet domain routing notations, or the listing of a security group is acceptable. Protocol can be TCP, UDP, or ICMP, and the port can be a specified port, or it can be a port range. So note that you've got tons of options for how you configure your firewalls. Firewalls by default will implicitly deny anything that isn't explicitly allowed. In other words, if there's not a rule over here that says that the traffic is allowed, it is denied. No, there's no negotiation on that. It's denied. So that's how security groups function, is they make sure that everything is denied except for what you've explicitly said yes to. So only allow rules, no deny rules. By default, a security group will allow all outbound traffic from an EC2 instance to the internet, but it will not allow the internet to get to an EC2 instance. So if you need to go retrieve security patches, awesome. But if you want to have somebody hit your web server, you have to specify that. But by default, all outbound traffic is allowed, all inbound traffic is denied. Now, here we are again. We're back at the VPC. remember that these subnets are actually inside of an availability zone. We've got a web tier, an app tier, and a database tier, consisting of web servers, app servers, and database servers, right? Now, notice that this is the security group for the web tier. It's allowing all traffic, including corporate traffic, to port 22. Note that the app tier is only allowing traffic from the web tier. So it's saying, you know what, if you're in this group, you can come to us. And that the database tier is only allowing traffic to the app tier, but all of the app and database tiers are allowing traffic across port 22 from the corporate network, which is that 10.0.16 network. So just know that security groups allow you to specify IP ranges that are allowed to talk to particular ports or ranges of ports inside of an EC2 instance. A EC2 instance can belong to more than one security group, but it must always belong at least to one security group. It cannot be launched otherwise. And notice the corporate network is down here, so if you want to see that IP address, it's down there as well, or network. Okay. All right, here's a knowledge check. Because we're switching gears, right? We're done with security. Which of the following best describes the types of data for which Amazon S3 Glacier is best suited? So let's just do this step by step like we did last time. 1, is Glacier ideal for data that's frequently erased within the first 30 days?
No.
I wouldn't even bother putting it in Glacier at that point, right? Right? Glacier is for long-term archival storage, not for 30-day storage. B, is available after a 3 to 5 hour restore period. Did we see anything about a 3 to 5 hour restore period for Glacier? We did, right? So so that sounds like that would probably be true, actually. By the way, there's a bulk restore period and there's an expedited, but for standard, we saw a 3 to 5 hour kind of standard restore period. All right, what about C? Is Glacier for stuff that's infrequently or rarely accessed?
Yes.
I think it is actually for infrequently or rarely accessed. It might also be good for stuff that's never really accessed, but I don't know. We'll see what the answer is. And then what about requires block storage? Can you mount S3 as a file system? Any variant of S3?
No.
No, this is not a file system. So it definitely is not going to be good for requiring block storage. So let's take a look and see what Amazon says. So definitely not good if it's erased within 30 days. Definitely requires block storage, but it's great if you want a 3 to 5 hour restore period or if it's infrequently or rarely accessed. That's good. It throws you off a little bit because there is an infrequent access tier. And I'm like, wait, if it's infrequently accessed, wouldn't that be an infrequent access? But it threw rarely in there, so we'll get it to them, right? Good. Okay, so the key takeaway here is that in every account, right, you choose your region that you're going to run. In that region, you're going to create a VPC. In those VPCs, you're going to put subnets that live in availability zones. This subnet, by the way, exists only in availability zone A. There will be a whole other subnet over here that would exist in availability zone B. Subnets cannot span availability zones. That shows up on the exam, by the way. And then we can host our EC2 virtual machines here along with their attached virtual hard drives. And they will have a firewall around them called a security group. And we can actually host objects like web-enabled objects in our S3 buckets. And we could create lifecycle policies to actually roll them over to Glacier if we just need to hold on to them, but we don't need to use them, which is what Glacier is really for. Storing objects, not using. And that's kind of how we've evolved with our services. Oops. Let's clear that drawing off.
Are S3 buckets and Glacier archives meaningfully constrained by VPCs?
They're constrained to regions, but they don't operate within VPCs.
Okay.
Yeah, so they're a regional service. They're not If the service is constrained to an availability zone, then they're constrained by VPCs as well. But if it's a regional service, then it's not constrained by a VPC. Since the VPC is a networking construct, as is the resulting availability zones inside, it's really only the services that run in availability zones like virtual machines or RDS databases that require the knowledge of availability zones and the resulting VPC. But otherwise, everything that's a managed service runs outside of VPCs in the region portion of the data center.
That makes sense. Yeah. That's why it's like funny.
Yeah. And this doesn't necessarily represent it accurately, because as you can see, they put the S3 buckets inside the VPC, and that's actually not how it functions. They actually run outside the VPC. This particular section right here, it actually runs at this layer. And how do we know that? Because there's actually a service called VPC endpoints that allows you to stick a network card inside of your VPC that will allow you to talk to S3 because it sits outside the VPC, right? And so they have a service to allow you to talk to the S3 buckets that are outside of your VPC without having to go across the internet. So that's how we know. That's how that works. Okay, so now we have our first lab, which is going to put us at webage.quicklabs.com. And we're going to create a bucket, add an object to the bucket, manage the permissions of the bucket, create a bucket policy, enable some versioning, and we're going to host a static website. So it sounds like a lot, but don't worry, it's all step by step. So if you log in to webage.quicklabs.com, your mileage will probably vary because I think I have the instructor's viewpoint, but you probably have a classroom or labs over on the left-hand side. And if you click on it, it should take you to, what in this case, the Cloud Practitioner Essentials. Hi, take me in. We've got 7 labs pre-warmed. Here's what will happen is that when you click into the lab, it's going to open up this amazing little interface, and you're going to see the Start Lab button on the left-hand side. You are going to click on Start Lab, and you'll see a timer. The timer is usually for either 2 or 3 times the amount of time that you actually need to actually do the lab, just so you're aware. And so in this particular case, we're actually going to spend about half an hour working on the lab. And actually, I can check that. Is it half an hour? Yeah, it's half an hour. So what we're going to do is we're going to spend half an hour looking at the lab. And what's going to happen is that timer is going to count down. When that timer finishes, by the way, it's going to delete everything. So you don't have to worry about shutting the lab down or anything. Your instructions are right here on this webpage. So that's why, by the way, they typically recommend that you have 2 monitors, or you can just, alt tab back and forth, whatever you want to do. But the tasks are step by step. So for example, once you hit the start button and you open up the console, which is going to try and log you in as the user. And by the way, the password's here is the account number. And notice that we're in Virginia, US East 1. You're just going to step by step follow the instructions. In the services menu, choose S3. So for example, if I was here in my particular thing, I would just go back into S3. That's all. Oops, log me out. And then you would create a bucket, and then make sure you follow the instructions, because if you miss an instruction, it will most likely throw an error and tell you. And all of the tasks are listed here. And so you're just going to start working through the labs. I'm going to hang out here and answer any questions that you might have as they arise. And typically, you're just going to run through and make sure you do all the stuff. And that's going to walk you through doing everything that we need to do for the S3 buckets. Questions? Is everyone logged in to webage.quicklabs.com? Is anyone not able to get in? Okay, we'll go for it. Go take a run at the labs. I'll be here to answer any specific questions that you have. Otherwise, that's what we're doing for the next 30 minutes. So at 11:30, we're going to resume. If you finish early, go ahead and take a break. But we're going to take our last 30 minutes and run through some material, and then we'll take a break for lunch, and then we'll come back and finish things up. All right, we'll see you in a bit. Okay. So building in the cloud. So Amazon's focus here is really about going beyond servers and storage, being able to monitor resources. So not just using managed services, but how do you monitor everything? How do you manage demand so that it stays, so that the capacity and performance stay pretty close together? How do you, are there database options? Because that's probably the next step, especially when looking at more of a lift and shift style migration. How do you drive automation, which is a key hallmark or facet of DevOps nowadays when you're trying to drive software delivery to be more efficient? How do you connect and share data? And then how do you deliver content faster to your users, which is something that we alluded to earlier. So one of the things as you make your journey through cloud is that you want to get to this space of reinvention where, again, you're not really messing around with servers and that you're really focused on services and how those services link back to your core value proposition, your business proposition for your customers. And so the journey here is to really get into more of a cloud native aspect, which is true regardless of the provider that you use, and kind of abstract away some of the daily concerns that are not a core differentiator for your business. Now, we've had our initial project. How do we then improve it? Because we've added persistent disk drives, we've added EC2 instances, we've added offloading for static content for S3 buckets. How do we add monitoring, for example, so that we can actually see failures before they happen and plan for failures? How do we improve performance, scalability, and utilization, right? Because obviously with EC2 instances, one EC2 instance is not really awesome. And then what about databases? Running a database inside of an EC2 instance is not a bad prospect, but is that core to your business, running databases, installing, patching, the whole, scaling them, the whole 9 yards there. And so what we're going to do is we're going to see if we can't improve some of those aspects. So the first is monitoring your AWS resources. So when you monitor an AWS resource, the primary service to think about is CloudWatch. CloudWatch has about 6 or 7 different facets to it, and new facets are being added all the time. Its main focus is to collect all the metrics around your services, send notifications if there are alarms, respond to events, and basically provide observability and telemetry into anything that you want CloudWatch to watch, basically. The way CloudWatch works is that if it's an AWS service or you're sending metrics to CloudWatch, they get sent to the metrics repository, which has certain numerical facets attached to it, like CPU utilization or binary checks, like did the status check fail or did it succeed? And then you can add things like latency, page view count. You could submit application metrics. So with AWS Command Line or SDK, you can actually submit your own telemetry and metrics into the CloudWatch system and have them alarm displayed, in your dashboards, basically. CloudWatch has a dashboards function. And then with CloudWatch alarms, you can actually set thresholds that either trigger actions or trigger notification, or both, if you want that, right? You can also set events so that if there's state changes, an alarm can trigger and things can happen. Like if something changes from like a security group changes to being wide open to the world versus before it wasn't wide open to the world. Or an S3 bucket changes its permissions to be public, whereas before it wasn't public, right? So CloudWatch allows you to centralize all your metrics to a single platform. You can maintain visibility across all of your applications and correlate events. You pay as you go. And it really can help you reduce the mean time to resolution, which is a key DevOps metric for stability, and drive insights, basically. You can get container insights, you can get managed service insights, you can get insights into all kinds of things with CloudWatch. And so that's what CloudWatch's main function is that is basically the metric service inside of AWS. Now, the other thing is that let's say you've got monitoring down and you're using CloudWatch for it, and you've got great insight in your services. And one thing you notice is that you're not able to keep up with demand. So AWS was started as a company, as a sub company for Amazon, because Amazon itself had a bunch of unused capacity, especially outside of Christmas. So they had a paper that said, hey, what if we actually just make this unused capacity available, because we're paying for all this capacity that we're not using for the rest of the year. Same thing with us. Scaling matters because we want capacity and performance to stay right above each other. right? Because that's maximum efficiency. That means that we are not paying for so much more than we need, because when someone says, I need this, our capacity to service that need is just ahead of their ask. And so scaling matters, because if you're over capacity, well, then the user's having a bad experience. If you're under capacity, then you're paying for capacity you're not using. So your ROI, your return on investment is really low. So EC2 has a service called auto scaling that basically adjusts the number of EC2 instances that you have in an EC2 instance target group or server pool. And it will allow you to scale up the number of web servers or up the number of application servers as demand goes up. It'll allow you to scale them down as they go down. And it will automatically replace unhealthy instances that have failed with instances that are working. Now, that does require some level of automation or imaging, but it's actually relatively simple to do. Now, there's a couple of different ways to scale, but you can set your minimum number of servers, your maximum number of servers, and your desired number of servers. And that can be done off of a schedule. You can actually hook it into CloudWatch and say, look, if latency goes to 200 milliseconds, add a server. If average CPU utilization hits 95% for 5 minutes, I want you to add another 2 servers. And it will keep adding servers up to your max that you specify inside the auto scaling configuration. And so in this particular case, it's added 4 more instances from the original, because all of a sudden there's high demand. And when there's low demand, it can go down to your business continuity minimums. Like you might have a business rule that says, look, we can't run less than 2 servers at any given time, because if one fails, the other one can take over. And so your minimum could be 2, right? And so you can literally follow the demand curve of your applications while using auto scaling with EC2. Auto scaling, from my perspective, is the secret sauce that makes virtual machines more efficient on AWS, because you're not going to pay for what you're using. You can give it back when you're not. Also replace impaired instances, which I think is what we talked about. It will monitor the health of instances. It'll also monitor the health of responses from that instance. How many times has a virtual machine been up? Looks like it's running the software, but it's not responding to any web queries, right? And by the way, auto scaling will run across a bunch of availability zones. So auto scaling will run region-wide. It's not just limited to one AZ at a time. You can run across all your availability zones inside of a region. Word of caution, when you use auto scaling, you almost have to use elastic load balancing, because elastic load balancing will allow you to distribute that traffic across all your load balancers. Otherwise, you're going to do something weird like using DNS, which DNS is not really well designed for that kind of thing. So you're going to need an elastic load balancer to run with your EC2 auto scaling groups. That's just giving you a visual for if an instance fails, right? It's going to replace it. Now, I mentioned this before. Here's elastic load balancing. An elastic load balancer is basically a virtual device that will distribute incoming traffic across a bunch of backend machines. There's a couple of different flavors of elastic load balancer, but they're all highly available. They will all health check the virtual machines they're interacting with, and you can terminate SSL TLS certificates on the load balancer itself if you want to offload that from the system. I kind of recommend that you keep going and encrypt everything, but you can't actually terminate it on the elastic load balancer. So there's a couple of different versions. There's an application load balancer, which will actually do pathing. So if you have /North America on your, like it's example.com/North America or /API/data/Europe/Asia, whatever, right? Whatever the pathing is, it will allow you to send it to a different set of applications. So application load balancers actually look at the path of the URL and can actually route the request to the appropriate target group or application, depending on what the suffix is, /images/API/data in this case. Network load balancers are the second type. Network load balancers just hook an IP address with a port. In this case, it's port 5442, which I think is that the port for Oracle? I don't remember actually. But port 5442, it basically, when it hits the network load balancer, it's going to route traffic either based on least connection or I want to say round robin is the other one. I'll be misquoting that actually, but it's basically going to distribute traffic in a random fashion across all those instances. There's a third type of load balancer that just came out actually within the last year. It's called the gateway load balancer. This allows you to basically run your popular third-party load balancers like F5s or the Cisco devices or like firewalls and stuff. They run in tap, meaning they're run in line, and it allows you to run them invisibly so that you can run load balancers, firewalls, and other network devices on your network pipes in AWS. You can even do like firewalls, like to do deep packet inspection or packet capture with gateway load balancers, GLBs. So here's the third type that's been out for about 8 months now. Okay, quick knowledge check. You have an application composed of individual discrete services, and you need to route a request to a service based on the URL or the content of the request. Which of the 3 load balancers did I just talk about that actually does routing and pathing? I don't think there's an auto scaling load balancer. Which are the other 2?
Application.
Yeah, application load balancer. The network load balancer is really just, in a sense, a simple load balancer. The application load balancer can actually do pathing and routing. And I did mention the gateway load balancer, which is that third-party type that can be inserted into line. Good, thank you. Any type of load balancer? Yeah, no. All right, let's talk about database services, because we've talked about monitoring with CloudWatch. We just talked about load balancing and auto scaling, which are 2 services that sit with EC2, right? And by the way, those sit under EC2 as well. Like in the console, they're actually under EC2. They're not separate services. So load balancing and auto scaling sit under EC2, so they're associated with virtual machines. What about database services? Well, here's the cool thing about the database ecosystem inside of AWS. Pretty much, if there's a popular open source version of a database technology, Amazon typically has it. So if you're looking for MS SQL or MySQL or MariaDB or Oracle, Amazon has a service for it. If you're looking for MongoDB, Amazon has a service for it. If you're looking for Cassandra, Amazon has a service for it. Hell, if you're looking for Kafka, which isn't even really a data store, it's kind of more of a streaming kind of like data repository service, streaming service, like almost like a bus, but a streaming bus. They have Kafka. They have a managed Kafka service out there, right? They also have Elasticsearch, Solr, Neo4j, which is a graph database. They have a bunch of database services. I think we're only going to talk about 2. So you can always, by the way, run whatever database you want on an EC2 virtual machine. It will be operating system specific, and it's particularly if you need specific like custom features of the database application, you can always run it on EC2. But there are a number of database services that are push button, highly managed, that are awesome inside of AWS that are actually also like super cost effective now, right? Especially in 2021. So this allows you, by the way, to not having to manage infrastructure or deal with databases. You just run the database and go away. So in this particular case, Amazon has a relational database service that will do automated software patching, automated backups based on maintenance windows and patch levels that you specify. It will run multiple availability zones. It will do encryption and rest, encryption in transit. It'll do automated host recovery. It'll scale with readers really easy, right? Because remember that, traditional RDBMS databases that are in like this system here traditionally only have one primary writer, right? They don't have multiple writers like a lot of NoSQL systems do. And so here you can support Postgres, Oracle, MS SQL, MySQL, and MariaDB. Note that Aurora, which is sometimes listed as an independent service from RDS, is a subflavor of the relational database service, and it's Amazon's cloud-enabled versions of MySQL and Postgres. So when you see Aurora, like in the upper left-hand side, those are MySQL and Postgres compatible databases. They run super fast. And there's even a serverless, which whenever I hear serverless, I hear hidden. There's even a serverless version of Aurora where you don't pay for a running database. You only pay for the data storage and any queries when they run. So Aurora has an interesting serverless option as well. God, I just went through the whole thing around Aurora, right? By the way, just so you know, if you take the same schema, same data set, same setup between a vanilla MySQL and Aurora, right, in RDS versus like plain Aurora, you'll find that the Aurora database system is 3 to 5 times faster, depending on whether it's Postgres or MySQL. It is crazy how much faster Aurora is compared to a traditional database setup inside of Postgres or MySQL. So Aurora is a subflavor of RDS. It's Amazon's special twist on MySQL and Postgres. Great product, super fast. Also has a serverless version, which is way cheaper. So when you're kind of like figuring out services, a lot of the questions is like, do I need SQL? Do I need a fixed schema? Do I want to vertically scale versus is it okay if the schema is a little bit more flexible? Am I not really using SQL? Is it key value delineated versus row, column, and table delineated? There's probably a bigger discussion around NoSQL versus SQL. Bottom line is that if you need a highly acidic transactional database, most likely a relational SQL-based database is going to be way better. If you just want to store blobs of data that it's okay if they're eventually consistent, and you're writing a lot of data, it's going to change infrequently, then a NoSQL database like a key value store is going to be better for you. DynamoDB is Amazon's flagship premier NoSQL database server. It is super flexible. It is a highly managed service. All you do is create tables, turn your dials on your performance, which by the way can be on demand or auto scaling, and then you just walk away. You just let it go, right? You just literally just like you run your queries against the API, pull data back, but you just let the thing figure out how to scale reads and writes, and it will do it for you. And you only pay for what you use. It can do multi-region replication, so you can actually globally replicate tables inside of DynamoDB. It also has an in-memory cache system that you can turn on that will get you to sub-millisecond like response times, which is a little crazy, honestly. DynamoDB is great for any kind of leaderboards, gaming, a data store for sessions, for carts, whatever. It can even be forced to be a little bit more acidic or transactional, so it can be strongly consistent if you want it to. But it's great for massive amounts of data. The performance on this thing cannot be underrated. It's amazing how fast and what volume of data DynamoDB can handle at large scale. And the global distribution and replication doesn't hurt either. Now, that being said, whether you're using RDS because you want an SQL-based transactional system, or whether you're using DynamoDB because you want a NoSQL system, remember that I just verbalized when we started about 10 different database services that are all pretty much open source compatible. Like DocumentDB in the middle there is MongoDB compatible. Neptune is a graph database that's got some Neo4j compatibility. Redshift, which is one of their oldest but iterated upon services, is a data warehouse based on Postgres. But they've got services for Cassandra, they've got services for Kafka, they've got Elasticsearch. They've got all of your favorites. They even have their own distribution of Elasticsearch that's a little bit more enterprise friendly. I like Elastic as a company, but there's been some controversy with them here recently. So as far as their licensing goes and pricing, but Amazon has their own version, for example, of Elasticsearch. They also have a database migration service. So something to be mindful of is that if you're in the console, assuming that Michael can find the console, excuse me for 1 second. If you're in the console, just know that there's a bunch of migration services in AWS that will help you like solve migration problems. The one that we're talking about here is the database migration service. But note that they have an application discovery service. They have an application migration service. They have a server migration service. They have something called Cloud Endure, which will allow you to replicate an entire data center with an agent on each system and replicate that into AWS like continuously. The database migration service is awesome because it'll help you replicate data from your data center into AWS, both one time or continuously. They'll even help you convert your database from one SQL system to another SQL system or SQL to DynamoDB. They'll help you convert Greenplum, Teradata. They have this schema conversion tool, which actually does a pretty decent job of converting schemas to the right format or version. So just know that there is a great database migration service. It's really rock solid out there. But the real thing is like, what do you need, right? Do you need an enterprise class relational database? Great, then RDS is going to be your friend. Do you need a NoSQL service and it's not Cassandra and it's not MongoDB? You just want a lightning fast, globally available service, then DynamoDB is going to be your friend, right? Maybe you need something really custom and specific and it's not going to run in RDS. Well, then just run it on EC2. Just put a database on your virtual machines and just run it there. Otherwise, there are specialized databases for almost every major popular use case that's out there in the industry that Amazon's hosting the service for. So questions, comments about what the services are used for RDS and for DynamoDB? Okay. Knowledge check. Which of the following is a key value NoSQL database? Good. Got a couple answers. It's good. Yeah. DynamoDB is the NoSQL system. Aurora, as a reminder, is a subset of RDS. RDS is the relational database system. So that's all of your traditional databases that we've been using since like, I don't know, 70s in theory, right? And then NoSQL DB doesn't exist. I don't, at least not that I'm aware of. There is, by the way, an old product called SimpleDB that is still out there running in some accounts. Don't use that product. That was their first stab at a kind of block store, not a block store, key value store, like a blob database. It's still out there running, but it's not listed on anything anymore. But the documentation is still out there and the API is still active. So just cracks me up. But DynamoDB is the answer here. Good. All right. We'll talk a little bit about automated deployment, but we're probably going to stop in the middle of it and just stop for lunch. So automation is a key facet of almost every single pipeline I've worked on. And the native tool for automating is CloudFormation. CloudFormation allows you to take JSON or YAML defined templates. Basically, it looks like code, really. You check the template into your CloudFormation engine, either through uploading directly or an S3 bucket. You create the stack based on the code. And then what happens is that the CloudFormation engine will make all of the objects you define. What are objects? EC2 virtual machines, VPCs, subnets, firewalls. You can literally define almost everything that's in AWS. You can define it inside of a JSON or YAML format, submit it in, and it will actually create it. It will actually even provision your operating systems using this framework called Cloud Init, which is pretty cool, actually. It's not as robust as, say, like an Ansible, a Chef, or a Puppet if you know those tools, but CloudFormation is incredibly robust when it comes to AWS infrastructure and can pretty much be used to do everything inside of AWS from a provisioning standpoint. You can even detect drift from your environment against your CloudFormation stacks, if you will, and you can share stacks with other accounts and use them as almost like a service catalog to provision resources in a very templatized or automated fashion. So CloudFormation is awesome. There are tons of CloudFormation templates out on GitHub that are really great. Some published by AWS, some published by the community. So in this example, you could actually use the WYSIWYG designer that they have called CloudFormation Designer. to derive a JSON template. Most people, by the way, don't do that because it's not as awesome as anybody wants it to be. But usually create your JSON, and then that creates your resources, right? Most people are switching to YAML, but JSON is still very popular. And that's what CloudFormation is for. CloudFormation is just used to derive and put together all the infrastructure that you need and define. So everything that we've seen, for example, in this particular map, you could actually define all of that. CloudFormation, submit it in, and then CloudFormation would make it for you. That includes your RDS database, your Elastic Load Balancers that we talked about, your auto scaling, your S3 buckets, your EC2 instances, as well as CloudWatch, setting up all the alarms there as well.
Mike,
yes.
If you were setting up, had plans to replicate that many times, or I don't know, do a bunch, would it still be better or best practice to build that using something like CloudFormation or script or something, rather than to just go fool around in the GUI or in the CLI and manually build it?
Yeah, mainly because it's going to be prone to error if you do it manually. If you do it through CloudFormation, it'll do it the same way every single time.
Okay.
Yeah. So typically, like doing some kind of automation or build script is recommended every single time, even if you're going to do it, if you only think you're going to do it once, because sometimes if you want to make changes, then you just make changes to the template and reapply it, and it makes sure that everything stays the same. Yeah. Okay. So it is like a minute before noon, and I promised that we would stop because it'll be 3.5 hours, and I want to make sure that our brains get a break and everything's like kosher. You get to like sink things in. We are actually going to keep moving on around automation and deployment and managing deployment. So we're going to talk about another service after this, but CloudFormation is the last thing that we focused on. Does anyone have any questions about anything else? Good question, by the way, before we take a break and come back at 1 o'clock in about 60 minutes.
Sounds good to me.
Okay. All right. Well,
sorry to stand between people on lunch, but where will we go to look for templates? I mean, you mentioned GitHub. GitHub's big and sometimes hard to browse. Are there like places where people post these and talk about them or rate them or anything like that? These templates to do common things?
Yeah, so let me do this, is that I will pull up some of the more better well-known repositories, plus some places where you can go and get higher quality CloudFormation templates, because there are people who specialize in that. Would that be okay?
That'd be awesome. Thanks.
Yeah, okay. We'll do that when we get back from lunch. It'll be the first thing we do. Any other questions? Okay. All right, so it is 12:01 by my watch. We will be back in 59 minutes at 1 o'clock. And so we will be right here. And so meanwhile, have a great lunch, and we'll see you in about an hour. All right, take care, everyone. We'll see you in a bit. Okay. All right, so let me share my screen, and let's talk about places to find CloudFormation templates. So let's see, one of my favorite places to get good templates is a company called, hold on, it's going to come back to me. Cloudknots.io, which this is a great place, by the way, just for learning in general. They also run another company called Wittix that does CloudFormation templates. And they're probably one of my favorite places, is that they have a repo and a website, actually, if you want to see it. It's part of their Cloudknot.io. This is templates. I'm actually going to post this into chat so you can have it. This allows you to get templates to work with a variety of different scenarios. But let's say you need to create a VPC, right? This will allow you to do that. And actually, if you click Launch Stack, it'll literally take you into your account, right? So if I click this, it'll literally, if I'm already logged into an account, it'll actually take me into my account. You can see it's Spartan and Forrester. And it'll literally start creating a CloudFormation stack. In this case, it's a 2 availability zone VPC, because it says 2 AZs VPC. And so they have 2 availabilities, publics and privates with 3 availability zones. They have them with 4 availability zones. Really, they have them with 5. If you also want to create a NAT gateway or a NAT instance or a Bastion host, these are all templates, by the way, that you can download. And on this website, they will tell you any prerequisites. So for example, you might need a VPC before you launch an EC2 instance. And so if you want to refer to the VPC you created, they'll tell you how to do that inside of the EC2 template. So here's for example, the EC2 templates. This is if you want to install it with Amazon Linux 2, private, public. And I feel like they've changed this recently. If you want to install Jenkins, right? Their Jenkins, by the way, their setup is absolutely spectacular. They also have it with dynamic build agents, so you can actually create other EC2 instances that actually do the work while the primary instance is there. They create a highly fault tolerant Jenkins instance. So if you're looking for templates, this is a great space to get some basics, including WordPress, static website. If you're looking for S3 buckets, that's under state or data. By the way, here's some DynamoDB tables, some Elasticache. They've got some really great templates in here. And so most of us don't write CloudFormation from scratch. We'll use, someone like this to borrow a template from. These are all free and open source. Like there's no licensing to them. The other website that I wanted to make sure that you are aware of, it's a little secret, just came out recently. It's called Former2. CloudFormer used to be an open source project that Amazon ran for years. They kind of abandoned it, and what it did is it actually created CloudFormation from your actual infrastructure. You could click on your infrastructure and it would create it. Great product. They abandoned it like 4 years ago, and so some new AWS, some new Amazonians actually picked it up. So what you do is you install the helper, but what it does is it allows you to drag and drop. Oh, I wonder why the helper's not installed. Anyway, doesn't matter. It allows you to drag and drop components into your own kind of Visio setup. I'm not sure why it's erroring out, but it usually works flawlessly. So it's definitely something with my setup. But you basically say I want to add a host or I want to add a load balancer or whatnot, and it will create infrastructure for you. Please write off whatever error is happening to my machine because it's been kind of finicky here recently. But basically you can drag and drop and create infrastructure, and it will do it, by the way, in CloudFormation or in Terraform, which is another great tool, right? So I'm not sure what's going on. This probably actually only works in Chrome. So let me just try this really quick. Compute. Anyway, the bottom line is that you want to hook up your account and then it will basically hook in. I'm not sure exactly what's going on, but again, it's going to be my problem, not theirs. But Former is the other, former2.com is the thing that I would highly recommend. And I actually post that link in chat as well, that you get your CloudFormation templates. The other place that's great, because I know I was like, hey, you can just search GitHub. And it's like, what? That's, GitHub is so large, right? What are we talking about? So you can actually come out here and look for AWS Labs, which is another great place to get tons of stuff. So where is it? And the AWS samples as well. Where's AWS Labs? Here it is. But AWS Labs is a great place to get CloudFormation templates. They've got a templates repository right here. This is actually the full link. So I'll actually post that in chat as well. But they've got community links here. They've also got official AWS by solution and by service. So if you click by service, they have every CloudFormation template that you'd be interested in, including everything from how to run a Cloud9 to, don't think I've seen the Elastic Kubernetes service out here, but ECS is out here, right? So this is probably the other great set of templates that I would do. So between those three, you're pretty covered on templates, because Former2 will actually allow you to create your templates from your existing infrastructure, but also from scratch. So again, ignore my earlier errors. I'm not sure what I was doing wrong there. Is that helpful?
That's super helpful. Yeah. Thank you so much. I feel
yeah. Good. Yeah, because honestly, there's a bunch of templates out there. not all of them are awesome. Just a general rule of thumb: if you decide to search for CloudFormation templates and you like grab some from the community, one, make sure you read them because they are a security problem. Just going to say that. Make sure you read them line by line because there could be stuff in here that you don't want, right? Two, make sure that the template is no more than like 2 years old, because after 2 years old, you start running into enough changes where the template's probably not going to work, so you're probably wasting your time. So if you do decide to grab templates out there just randomly, make sure that you are grabbing stuff that's 2 years or younger, and make sure you read everything line by line. Because if you don't know what it does, it's doing something and it may not be what you want. So, cool. No, that's going to bug me. I'm going to have to figure out what's going on with Former, but that's okay. All right. So, where were we? Oh, yeah. We had just gotten past CloudWatch. We had just talked about scaling with auto scaling and load balancing. We had talked about database services, including DynamoDB and RDS, as well as the database migration service. And we just talked about CloudFormation, just prompted that last question. And then we were right here, and the question was, how do I deploy without managing infrastructure? So just know that in addition to CloudFormation, which you can use to automate pretty much everything inside of your account, you can also use, there's some great wizards inside of AWS. One of the great wizards is called Elastic Beanstalk. This service has been around forever, but it is a pretty much unknown service, and they have been iterating on it like crazy. Beanstalk is basically a wizard for best practice standard EC2 deployments. So like it'll do multi-AZ, it'll add a database to the back end, it will do blue-green deployments for you, it'll handle auto scaling, it'll set up CloudWatch, it'll do all that for you. But Beanstalk is very simple, although it can ask some very complex questions, and it's not great for customized architectures. But it's really great if you're like, hey, I'm a developer, I don't really have time to learn all the architecture stuff. Is there just a best practice way that I can do to like make this happen? Yeah, Beanstalk. So Beanstalk is, if you look at it in the console, it's an interesting product, because what happens is that when you launch Beanstalk, one of the first things it's gonna ask you like a bunch of questions, because you actually create a Beanstalk managed environment. And when you create an environment, it's going to say, hey, is this a web server environment? Because that's what it really specializes in. Or is this some kind of asynchronous worker environment? And then past that, what will happen is it's going to say, okay, what do you want to call this, right? Let's call it an Nginx test or something. In what's the environment name, right? And so it's just going to add env. If we want to create our own custom domain, we can do that as well. It'll say, hey, do you want to have it managed, or do you want to create a custom platform? Now notice that right now you have to choose. Then you choose your language. Is it you want to run Java? You want Ruby? You want Python? Is it just straight up Java, or is it Tomcat? Do you want to run Docker, right? Or do you want .NET on a variety of different environments, right? And then you pick your version, which usually goes back like 2 or 3 versions. You pick the platform version that you want to use, the version of like the Python platform, right? And then you can do a sample application, or you can just upload your code if you want to. And that can be an S3 or a local file, and you can add tags to it. And then what happens is that, then that's it. If you want to configure more options though, if you want more, then what will happen is it'll give you a whole bunch of other questions like, hey, I want high availability and I want high availability, but I want to use a mix of EC2 instance types, right? And you could come in here and enable insights. You could enable log rotation. You could stream logs, right? You can do all kinds of stuff. You can say, look, I want to change the deployment policy, and instead of doing a rolling update, I want you to do an immutable update. I want you to ignore health protection. You can actually change all kinds of stuff in here. There are so many questions if you get into the details. You can change the network. You can add a database if you want to, right? I don't know what the actual latest database options are. Is it all RDS? Yeah, it's a transactional database. So this is really like your traditional kind of like triple, 2 to 3 tier web app that you can deploy. So this is actually just kind of a wizard where you answer a bunch of questions and it does best practices for you. That's really all Beanstalk is. It's a great product, very simple. It's a great place to start. Isn't typically a place that you stay, right? And that's Elastic Beanstalk.
Once you set up an environment with Elastic Beanstalk, do you just manage it the way you would manage another environment, or is it managed by Beanstalk? Do you have to migrate out of it somehow if you want to do fancier stuff?
So it depends. If you said that you wanted it to manage it, then you typically don't touch it. That doesn't mean you can't get in there and change it. You can actually, but if you want it to be custom managed, that means you're going to do most of the management. So it depends on which of the paths you choose. Either way, you can change it. Just know that if you change a managed system, it can wreck the management of the system, like the automated management.
Sure. Okay.
Yeah. Yeah. Okay. 2 more sections left before we roll into the lab. How do we connect and share data? All right, so we've got a hybrid cloud. So we've got our EC2 instances. They're in an auto-scaling group, so they'll add instances, remove instances. Those instances have persistent storage, which is what the EBS volumes are for. And we've got our internet gateway, but everything's hitting us through the internet. Like clients are coming in through the internet, so is the corporate data center. What if we don't like that? What if we don't want our sensitive and we need highly performant connectivity that is not subject to internet weather? Because that does everyone know about internet weather? Like Netflix, like at 10 o'clock at night when Netflix traffic surges to be like a third of the internet, that slows down a bunch of things that run across the internet, right? As well. So like, what if you don't want your traffic to be subject to that? Well, the cool thing is that what if that was a problem, your network connectivity, but what also if you were running out of storage, as an example, or even compute inside of your corporate data center, and you wanted to continue to use the cloud and see if cloud could somehow offload your storage concerns at the very least, if not your compute concerns. And then what if you needed your EC2 instances to also talk to your corporate data center and vice versa? Like, how would you create network consistency, offload your storage, but also make sure that your cloud instances could talk to your on-site servers? How would you support that? Well, the answer is, from AWS perspective, is that you could actually just run a cable from your data center to Amazon's data center. What you actually do is you run it to a partner, and the partner runs it over to Amazon's data center, and it's a dedicated pipe. They come in 1, 10, and now 100 gigabit flavors. Gigabits, right? So like this can be a really fast dedicated connection. So it allows you to reduce network costs because so maybe something most of you may not be aware of is that Amazon will not charge you to put data into AWS. But when you pull data out of AWS, they'll charge you fractions of a penny. And that can add up when it hits terabytes and petabytes and exabytes of data, right? When you do a direct connect connection, the cost per gigabyte goes way down. It's consistently low. And it provides dedicated connectivity to your VPCs. And if you use a transit gateway, it can actually provide connectivity to all of your VPCs, not just one. Here's an example. Got the cloud on the right. We got the direct connect partner location. And then we've got your corporate data center. So you connect to the partner. And then what ends up happening is that the partner then has a direct connection over to whatever services you specify. So you create the direct connect endpoint in your console. You connect your corporate data center physically with a wire to the partner network, and the partner network routes it from there. And so it is actually, in a sense, a direct physical connection. It's dedicated. There's no internet weather. No one else shares it. It's just for you. And if you want to encrypt data on it, you can do that as well, but there's no one else on the pipe. So it's literally a dedicated physical connection to Amazon's data centers. Now, in addition to having a dedicated connection, if you need your web servers and your corporate servers to talk to each other based in cloud versus corporate, Amazon has a domain name system called Route 53, which is actually it's actually a full registrar. It's not like super price competitive. You're not going to find $8 domains on there. But it is an enterprise class DNS system they go for 100% uptime. Like that's their thing. It's 100% up, right? And they do route internet traffic. So you can actually create privately hosted zones and publicly hosted zones, which allows DNS to either privately resolve for your internal network or publicly resolve for client networks. So you can actually route between your corporate data centers and the internet. Route 53, by the way, will connect with load balancers to make sure the instances are healthy. And Route 53 has a number of really awesome failover policies that allows you to route traffic between two data centers. If one fails, it goes to the other one. You can route traffic based on country. You can route DNS traffic based on location, like latency or proximity. So Route 53 has a number of kind of routing policies that will allow it to do a version of high availability at a global level, depending on what you're looking for. So Direct Connect is a physical network connection. Route 53 is the domain name system that lives inside of Amazon. Here, by the way, you can see that sales.example.com resolves via Route 53 to an elastic load balancer inside of the VPC. That's actually not how that works, but whatever. It's actually a load balancer at the regional level, right? But I guess they do technically exist as a device inside the VPC. But basically, it will route to any of the devices in any of the availability zones. Now, we've solved the problem of how to create consistent network connectivity by having a dedicated pipe. We've solved the issue of being able to have servers find each other, whether they're on a corporate data center or a cloud data center, because we have now the domain name system, which can be pointed towards them. What if we were having a storage problem and we needed to basically share a network mountable point, like an NFS, for those of you who use Linux? If we needed to do some network storage and we needed to mount that across the entire region. So we have 1,000 web servers. We want them to all mount the same HTML directory. And I can make a change to the HTML directory and have it go out to all of the web servers. Well, you're going to need basically network-enabled storage to do that, and that's what EFS is. EFS is a shared elastic network-enabled file system for Linux particularly, not for Windows. So Linux will run this almost natively. Super cost-effective. It will actually span an entire region. So you can literally have every single availability zone with EC2 instances in it, mount this storage, has a directory inside Linux. It's a shared file system, fully managed, and you can turn the dial on performance as you need to. So if we put that all together and we say, look, I've got my EC2 instances in a scalable group, auto-scaled. I've got a load balancer in front of them. That's, traffic's coming from the internet gateway. Then on the back end of those systems, I can have an elastic file system that will handle scalable storage. And I can actually have Route 53 connect my corporate data center domain names with my domain names in the cloud. And I can run all that over a direct private connection called Direct Connect between my corporate data center and my AWS data centers. Okay, that's all, by the way, stuff that's happening inside of our data centers relevant to like our corporate connection, right? Well, what about globally? What if we need to deliver content faster globally? Well, oddly enough, I feel like I could have written this because I actually ran a company that did this, is that we would ingest encoded video after it was copied to an S3 bucket. We would convert that video to desktop and mobile versions, including a voice-only transcription. We would then strip out the metadata about the videos so people could search and find the video if they needed it. And then we would put it in another bucket, and then we would stream the bucket out to clients. But we used a content delivery network to stream the data out because our bucket only existed in one location. So how do you feed content out globally to the world when all of your data is in one location? Well, you need low latency distribution for that. And you may remember those edge locations, which were different from the availability zones in the regions. This is where the edge locations come in. So what you did here is that how do we create a service that can do all these steps and then distribute across the entire globe fast access to these converted videos? Well, the first thing that Amazon's going to suggest is that for these processes that where you convert and transcode all these videos, why don't you just use Lambda? Because you don't need servers for that. We ran in a company entirely with no servers, at least for our core products. So what you do with Lambda is you upload your code to Lambda. You like set what the trigger is going to be for your function or code. Lambda is going to run, and then you only pay when your code is running. You do not specify any servers here at all. You don't have to put this on a network. You don't specify the size of the machine. You don't patch the machine. All you do is upload your code, tell AWS what the trigger is and how many resources you need, and then it runs on the trigger. By the way, the trigger could be time. The trigger could be someone uploading a file to an S3 bucket. There are lots of triggers to get Lambda to run, right? And then you only pay when the code runs. If the code's just sitting there doing nothing, you pay nothing. If the code runs 1,000 times, you pay for 1,000 times of usage based on time. If it's 1,000 times and the average was 20 seconds, that's probably going to be your average pay scale. So Lambda, so if EC2 instances are for an operating system hosting of virtual machines, containers are process isolation, which we haven't even talked about containers yet. Lambda is above that where it's just code. There's no environment. You upload it in and Amazon runs it. Now, the benefits of Lambda is that it supports a lot of programming languages, completely automated. You get amazing concurrency. You could run 1,000 parallel processes with Lambda. You can actually also chain Lambda functions together because there's kind of an important point that you should know. Lambda functions or code runs in Lambda are limited to 15 minutes. So if your process takes longer than 15 minutes, you're going to need to call another process to pick up the slack, just so you're aware. Lambda, by the way, it has built-in fault tolerance. You pay per use. It's an awesome product, especially if you can deal with the 15-minute limitation. Know that they also have step functions, which is a way of orchestrating multiple Lambdas to run together. So Lambda has probably been around since 2013, 2014. Super hot, great way to run your code if you don't need it to run 24/7, and it's a event-driven architecture. Meaning something happens, your code gets called. Something happens, your code gets called. Not just someone like browsing a website. Lambda's not great for like website hosting. Here's an example based on what we talked about earlier. Here, someone uploads a thumbnail. Sorry, let's say it's a video or a picture. They upload it to a source bucket. Lambda gets called because a file was put into the source bucket. That calls a set of permissions called an execution role, also now known as a run role, right? And what will happen is then it will create the thumbnail and then put the thumbnail into the target bucket. And then you can send a notification out to the user and say, hey, your thumbnail's right here. No servers, right? Just Lambda and S3. So think of Lambda as the serverless component of the three tiers of application hosting. So there's serverless, which is with Lambda. There's containers, which there's an Elastic Container Service and a Kubernetes service, which we haven't even talked about. And I don't think we do talk about. But just know that Amazon has 2 services for running containers. And then there's virtual machines, which is the basis level of hosting, still very much in use today, where you have the most control, but you do have to patch the operating system. So there's virtual machines, containers, serverless. Lambda is the serverless tier of application hosting. It's the one where everything is the most abstracted away from you. Questions about any of that? No? Okay. Okay, here we go. First question. What's the first step in getting started with AWS Lambda?
Delta.
Delta? Did I hear Delta? Is that what I heard?
Yeah.
Yeah, that's it. You just upload your code, right? Once you upload your code, you answer a few questions, you're done. I would be totally remiss if I didn't mention Lambda has a bunch of pre-created templates and filters for you already. So, hold on. I don't want to create a layer. How about an application? Thanks. They, by the way, have like, you can do it from notification. You can create a backend. They have sample applications. They're ridiculous. You can also deploy an application from what they call their serverless application repository, right? This is available to every account, by the way, not just from me, right? You can use a blueprint. You can build it from a container image if you want to. You can browse the serverless repository if you want to like just look through the whole thing. Everything from Alexa skills to hello worlds from Pythons to a Datadog log forwarder. There's tons of stuff out here. So don't feel like you got to write this from scratch. If you want to write a Lambda function, there's a web scraper right here, right? Like there's tons of functions out here, right? That you can just use either as a base template or just use as is. So yeah. There's tons of aspects to Lambda that are just awesome. And so just know that there's a bunch of pre-created like stuff out here for Lambda. All right, upload your code is definitely the answer. All right, last little bits here before we roll into our lab is that Amazon does have push-pull mechanisms for event-driven architectures. So for example, SNS is the notification system, but it doesn't just have to deliver emails or texts. It can actually deliver a web post. You could trigger a Lambda function. SNS is like the fan out, like kind of like push system. When you subscribe to an SNS topic, you then will receive any messages that are posted to that topic, whether you subscribe as a web post, as a text, as a email, it doesn't matter, right? SNS is awesome because once you have the topic, you have a publisher who pushes to that topic after the subscriber has agreed to subscribe to it, and then it will go out and just fan out to everybody concurrently. It doesn't guarantee time of delivery, or even it certainly doesn't guarantee order of delivery, right? But it usually guarantees delivery. Now that's the push model, right? That's the fan out model, right? Think of this as the pub sub model also. Now that's one way to push notifications and content out, but what if you need to get your videos, your JPEGs, you're closer to the user, but you're in Virginia and a large number of your user base is in Tokyo? How does that get fixed? Well, in this case, let's say a person from Tokyo comes in and you're not running infrastructure anywhere in Asia at all. And by the way, there's probably a cache server closer. Like maybe this person's in Russia, for example. So they go to hit some content and CloudFront's already enabled for the content in question. And instead of going all the way back to the S3 bucket over here to get the content, it actually goes to the cache location. The caching location, if it doesn't have a copy of what the user requests, it goes all the way back over a high-speed connection. It goes to the S3 bucket, grabs a copy, puts it in the cache, and then feeds it out to the user. Now you might say, well, Michael, that sounds like that might be slower. Well, for the first user, it's probably about the same, if not faster. Because instead of running across the internet, they're running across the private Amazon connections between Europe and North America, right? And so the first time it may not be faster, but when the next user in Russia and the next user in Russia hits that same content, it's going to be faster because it's not going to go back to the source unless you've expired the content. So this is what a content delivery network does, except it does it automatically for millions, or if not billions of users all over the globe. Although I don't think most of us have to do it with billions of users. Let's say thousands and tens of thousands, right? And what happens is it hits the cache locations. And if the cache locations already have a copy of the file that's being requested, it doesn't go back to the S3 bucket to get it. It just stays right there. Now, in addition to being able to cache content globally, which is what CloudFront does, You can also cache your database results, which is kind of a form of local caching. So Amazon has a product called Elasticache, which does local caching of database results. So we're still on that, how do we make things faster kind of rubric, because when we were up here dealing with SNS, that was really just about driving event-driven architectures and sending notifications. But with CloudFront, we were trying to make global content faster by pushing it closer to the user. Same thing with Elasticache. Elasticache, if you have really expensive queries that are repeatedly being run against your database, you can cache that content in Redis or Memcached, and it will be much faster. Now you have to figure out your caching strategy. Are you lazy loading? Are you doing write through or whatnot? But just know that I said before that Amazon has a lot of open source database technologies disguised as services. Well, this is Redis and Memcache, which are open source products disguised as the Elasticache service. This service has been around for a while, highly iterated upon, very stable, super fast, can be expensive if you misuse it for the value. So make sure that you're getting value out of your Elasticache clusters when you use them. Okay, so let's see if we can string some of this together, okay? So we've got our videos and we were uploading them to an S3 bucket and we want to accelerate the uploads. So we've done S3 acceleration transfer, so we're bringing CloudFront into the equation, right? Then that bucket gets loaded with a file, which spawns an SNS topic, which then calls a number of different Lambda functions that are all going to do media conversion. So they're going to do an audio only version of the video. They're going to do a 360p, a 480p, and then a high definition version of the video file. And then once those 4 Lambda functions are done, they're going to put that file in a playback bucket, an S3 bucket, which is then also going to get picked up by CloudFront and then fed out to the user, streaming as fast as it can, as close to the user as it can get. In addition, not only is that going to create a variety of different sizes of media so that the user can get it faster, but there's going to be another Lambda function that gets called to create metadata of the video. So like if the video has like cats or parachuting cats that are on fire shooting lasers, someone can search for parachuting cats that are on fire shooting lasers and get that cat video that will utterly complete their lives. Just kidding, obviously. Although maybe some people would argue, right? Now, let's say that you're getting hit for a lot of searches because people love cat videos about cats who are parachuting on fire with lasers. And so you could cache those queries in Elasticache so that when the queries, instead of always going to DynamoDB, if like 1,000 users are making the same search, they could just hit Elasticache instead of hitting DynamoDB directly. That was a lot. Giving you a moment to think. Questions? Cool. Okay. So here's some takeaways. There was a lot here in this module. We talked about CloudWatch, which is used for monitoring. We talked about load balancing and auto scaling, which, by the way, are the secret sauce that makes EC2 instances not just another expensive data center, right? So keep that in mind. You can even, by the way, set up auto scaling groups of 1. Like if you have a Jenkins server, for example, and you want to make sure that if it goes down, it restarts, you can create an auto scaling group of 1 if you have your backup system set up properly. There's also tons of database services, everything from NoSQL to Memcat, like the whole 9 yards. There's like, I think there was 11 database services the last time I looked, all, by the way, based on open source analogs, except for DynamoDB. DynamoDB is their flagship NoSQL service. That's the only one. Actually, it does have an analog. You could run React. React is actually an open source version of DynamoDB. So actually, I stand corrected. They're all open source. CloudFormation, along with Beanstalk, can be used to create, wizarded, kind of templated infrastructure. Direct Connect will give you a direct connection to your data center. Route 53 is the DNS service. Lambda is the serverless version of hosting, application hosting. Remember the 15-minute cap on running a single function. And then CloudFront was in there because you can push content closer to the users. so they can get your static content or your streaming content faster. Questions on any of that? Okay. We are going to be moving on to our next lab. In this lab, we're going to be creating VPC, creating subnets inside the VPC, configuring a stateful firewall known as a security group, and then we're going to launch an EC2 instance inside the VPC in the subnets that we created using the security group that we created. So we're gonna piece it all together. So off to webpage.quicklabs.com. So here we are. Let's see. I think these have all been pre-warmed. Good. I'll go ahead and hit the start button if you haven't already. Here's all your tasks. We're typically allocated 30 minutes for this. But sometimes I give just a little bit of extra time, like 40 minutes or so. But let's plan on 30 minutes and we'll see how far we get. So if you can work intently, you've got 3 basic tasks: create your VPC, create your security groups, and then launch your web servers. So go for it. Speedily work through. If you finished a little bit early before we check in about 30 minutes, take a break. Otherwise, go and conquer your labs. All right, let us move on to the next set. Okay, so let's talk about security. So this is a general statement about security, and we'll get to some specifics. Just know that there's a whole initial course on security essentials, and there's a 3-day basic and a 3-day advanced class on security engineering inside of AWS. So just be aware that the topic is pretty broad. So our goal is to just talk in general about things to consider when securing your infrastructure, how to manage user authentication, authorization, and access, which is probably the first thing we do when we deal with AWS accounts. How to assess your security and compliance, how to protect your infrastructure from distributed denial of service attacks, and how to maintain compliance. So, good stuff. All right, so let's talk about security. So Amazon is first and foremost, I would say, a security company because that was the number one objection to using cloud back in 2006, 7, 8, 9, etc. Is that, what was AWS going to do for me, right? That I couldn't do myself. Well, now, AWS's focus is that they secure the components of the cloud. So this is the hosting, the fundamental infrastructures, anything else. But anything that you put in the cloud or anything that you start in the cloud that you can actually access, like if you start an operating system and you can log into that operating system, you have to patch that operating system. If you start a database and you can access the database, but you can't access the operating system, you're only responsible, excuse me, for the database. If you put data in, but you can't manage the storage subsystem nor see it or anything like that, then you're not responsible for anything but the data and any of the configuration toggles you flip. This includes things like enabling client-side encryption or server-side encryption or network traffic protection if you have services to enable to make that happen. So AWS has security of the cloud. Customers like ourselves, we have security in the cloud. Now, this is the shared responsibility model, which is not just specific to AWS, although AWS certainly talks about it quite a bit. But they take care of everything, all of the physical infrastructure, all of the foundational services, all the hypervisors, the networking switches, the compute. Underneath everything, they take care of all that. Now, who's responsible for what? Well, if it's an unmanaged service, then you're responsible for things like OS patching and anything you put on there, right? The firewall configuration, disaster recovery, user data. If you call a third party, that's you responsible for what that third party does, right? If it's a managed service, then you're really only responsible for the things you stick in there and the feature toggles. But just to say that, I don't know why they put EBS there, because that is actually a managed service. I'm not really sure what they're doing. I think they meant to put EMR there. EC2 and EMR are the two main, in Lightsail, are the three services that allow you to log into an operating system. They are relatively unmanaged, right? EBS is actually pretty tightly managed, so I'm not sure why that's listed. Now, I'm going to switch over to the console for a second because the sheer number of security and compliance products. Let's just take a look at the console for a second. The sheer number of products here under security, if you look under, is ridiculous. So some of it's basic, like user management, like application user management versus like AWS user management. Some of these services are actually machine learning services that will actually do like PII scanning. Some of them are actually watchdogs that will protect your network. Some of them will actually do vulnerability scanning and assessment against standard CVEs against your operating systems. Some of them integrate you in, so they federate you with like Active Directory. Some of them provide keys, some of them provide certificates, some of them provide single sign-on. Some of them are web application firewalls, which are pretty well known. So there's a bunch of services out there. Like Detective is a weird service because it's a visual forensics service. So you can correlate data and get to the root cause of an issue. One thing that everyone should know, though, is that AWS Artifact is in every single AWS account. And when you go into it, if you're searching for something like FedRAMP and you're looking for, the SSP templates or whatever, every single AWS account has access to all the certifications and attestations that AWS has. So you can literally click on this and then download the report, and it will download it. Remember, this is Firefox, right? So it'll download the report. If you're searching for something else, like, I don't know, ISO anything, right? 27001 varieties, right? If you're looking for that, you can actually get the attestations for the statement of applicability and anything else. So anything that you're looking for from an attestation and certification standpoint is actually in your AWS account. You can also find some of these publicly, but not all of them are public. I don't know why. Now, having done several audits with AWS, just be aware that AWS will handle their side of things privately with the auditors, but AWS has a ridiculous number of like certifications. So if you go out there and take a look at their kind of like compliance segment, oh, where is it? They have this great list. Now I'm like, where is it exactly? They have this great list of all their attestations and compliance programs. Maybe it's over here. Oh yeah, here it is. So they have global certifications. They have some that are specific to the Americas, like ITAR, FIPS, FedRAMP, FISMA, that kind of thing. And again, not all of these are, anyway. If you're in security, you know which is which. Asia Pacific, and then they have, of course, Europe, Middle East, and Africa. So they have all the different attestations, certifications are listed here. Not every service is compliant with every one of these. So make sure on a service by service basis, you are evaluating whether or not they meet your certification and compliance needs. But I just wanted you to be aware that Artifact inside every account contains security attestations and whatnot. Okay, now the main ones that we're going to talk about are IAM, which is basically just user management for AWS, Inspector, which is like a network and OS vulnerability scanner that you can run inside your virtual machines, and Shield, which is included by every single account by default. So IAM, oh, I didn't see what Shield was. Shield is basically a distributed denial of service protection. So DDoS protection is what Shield provides. It's turned on by default with every account. So IAM is really just user management and group management and role management for AWS services. It can be federated with other OIDC and SAML compliant systems. I feel like there's something else to say there, but I'm sure it'll come back to me. So you create users. Users can have policies, which are collections of permissions attached to them, or users can be put in groups which have permissions and policies attached to them, or you can basically allow a user to assume a role, and a role is just an entity. It's like a disguise of permissions that you can put on. So if you're like a regular user and you need to elevate your privilege access to access another account, that other account could have a role that says this user in the other account can actually assume administrative access in our account. So a role is just a temporary set of permissions that you allow someone else to use so they don't have to change their username and password. If you, for example, are managing 50 accounts, do you want 50 usernames and passwords? That's probably trivial with things like OnePass and LastPass and whatever other password manager you're using. But it can get to be a pain to a certain degree to administrate, especially with password expiration and whatnot. So what you can do is if you have 50 accounts, you can actually have one user in the primary account and roles in the other 49 accounts. The user can take on the identity of the role when they're doing stuff in those other accounts. Think of it as the same as if you're a Linux admin of typing in sudo or sudo in order to get root access to another user, right? Roles allow you to assume another identity without changing your core identity. So when you use the CLI, the command line, the SDK, or the management console, you have to log in as a user. Now, preferably, there's only one user that sits outside of IAM, and that's the person who creates the account, and that has an email address associated with it. And you don't ever log in as that user once you've created an IAM user. So you don't ever use the root user or the organizational owner's account ever again once you've created an IAM user, unless Amazon needs to talk to you about something, and then they'll email that address directly. So it has an IAM user inside of an account. What can you do? Well, you can do nothing until someone gives you permissions to do something. And so there's an implicit deny for access to all services unless someone says, yep, you can read only this bucket. You can actually access this through a command line. And so once you've been granted permissions explicitly, you can do things. But without explicit grant, everything is an implicit deny. Word of caution. If someone comes in and says, you are explicitly denied, not by default. Someone comes in and says, Michael Forrester, you can't do anything. No amount of allows will ever override an explicit deny. Explicit denies are the highest form of permission. Explicit allows are the second form, highest form of permission, and the lowest form is implicit denies, because that's what happens by default. So an explicit allow can override an implicit deny, but an explicit deny, where you explicitly say, Michael Forrester, you cannot log in or do anything, no amount of permission granting will ever override that explicit deny. You have to remove the deny first, then allow things, and then the user will have permissions. Now, I mentioned roles before. Roles basically allow services or other users to assume another identity. So like if you have an EC2 instance running on, and there's an application running on it, you can actually grant that EC2 instance a role, which basically allows the application to now speak to an S3 bucket. Without that role, that application has no permissions, because EC2 has no permissions. But if I give that EC2 virtual machine permissions to talk to the bucket, the application that's on that machine can then talk to that bucket. Remember, roles are ways for you to assume permissions without changing your core identity. So as like a kind of like a social example, like I'm a father, a son, and a brother. If I go over to my mom and talk to her with the same set of permissions that I talk to my son about cleaning his room, which doesn't happen very often, it's actually a pretty casual conversation. But still, if I was like, hey mom, just so you know, like your room's kind of messy and that's not really our standard. I think you probably need to clean it up and let me know when that's done. I don't have those permissions with my mom. Societally, I have son permissions. I don't have father permissions, right? Now, if I walk up to my sister and I'm like, hey, Lori, man, your room is trashed. It's kind of a dumpster fire. I expect it, at the tender age of 52 that you might consider like cleaning your room more often, which of course would be kind of inflammatory to even say to her to begin with. But regardless, she would laugh at me, right? She would laugh at me and be like, get out, because I don't have father permissions. I have brother permissions with her. Now, that doesn't change who I am. I'm still Michael Forrester, but I have different societal permissions with different people, right? Same thing with AIM roles. You still get to be your user ID, but that allows you in other contexts to assume different permission identities. So you can get different sets of permissions. Again, the root user, don't use it. Don't put any keys on it. Don't log in as it. Create an IAM user with administrative access, and then enable MFA, and then move on. Don't log in as this user if you can again. This is the user. This is the email address that you use to create the account. When you create your own personal accounts, which I highly recommend all of you do, don't use, by the way, your Booz Allen Hamilton email address, or you will get called by security and your manager will get a notification. So don't do that. Just use the Gmail address or whatever other email you're using. But when you create your own account, don't ever log in as that account again if you can. Just put that password away, set it aside, and then log in as an IAM user, right? Any questions about any of that? About either roles or logging in as the root user?
Is there a role that you would recommend assuming for your first IAM user that presumably has fairly broad permissions but is not the root user?
I would actually just recommend that you give yourself administrative access to begin, right? And then what I would do is I would start, if you're exploring, I would pare it down. But like, for example, you may have seen earlier that I was trying to figure out why former was. I don't know if you, because earlier when we were here, former wasn't functioning, right?
Mm-hmm.
I couldn't get it to load. And so when I was going through the setup process, it said, hey, why don't you give us a user, right? And so what I did is I actually went into IAM and I actually created a role for former. Actually, I'm sorry, I didn't create a role. I created a user. Just to be clear, roles only work on AWS infrastructure. And since former is actually an external website, I actually went in and created a user for former called read only, right? And I actually gave it read only access. Now this is not administrative, that's not the right word. It is all services read only access because I wanted to be able to allow former to read everything. I don't know how it got desynced, but basically it basically wasn't able to read anything. So now if I scan my entire account, it's able to do everything. So if you're worried about someone hacking your account, then you might want to do a limited set of like a policy like power user, for example. So they do have like power user roles that you can use, and power user access provides access to services, but that doesn't allow management of users or groups. That would be the other thing I would start with. But quite frankly, if it's your account and you're not going to be throwing key access to secret keys everywhere, then you might just want to give yourself administrative access so you can play, and then start paring things down as you learn the services better. Like I have several accounts. There's my primary account, there's one for my laptop, there's one for Jenkins, there's one for Terraform. Those all have, in some form or fashion, administrative rights, but I've also put permission boundaries around them that allows what those administrators can do. So it looks like I've got full administrator access, but what actually has happened is I have a permission boundary around it that says you can only touch the services, right? So there's several different ways to approach that, but I would probably go for power user if you're concerned, and then, or administrator if you're just messing around. Does that make sense?
Yeah, definitely.
Good. It can be a fun exercise, by the way, to limit yourself for permissions and be like, okay, what permissions do I need to actually run the thing that I'm trying to do? Because obviously in an enterprise setting, it's always least privilege. You never give somebody more than they need. But for learning purposes, you might go above and beyond. All right, here's some best practices. 1, don't use the root user for anything. Don't log in. Make sure everybody has MFA. And you can actually create policies that say that people can't log in unless they have multi-factor authentication enabled. Try to follow the rule of least privilege and only give people the minimum amount of permissions they need if you're working in an enterprise setting particularly. Make sure that you set up a password policy and that you expire credentials on a regular basis. With today's password managers, that should be a pretty trivial non-event to kind of like manage and set up. People get annoyed when password expires and they talk about how ineffective it is. But when it comes to infrastructure, it's really not negotiable. And then make sure you're monitoring activity in your account. AWS has AWS Config, AWS CloudTrail, and CloudWatch. CloudWatch we talked about already. Those 3 services, Config, CloudTrail, and CloudWatch, are pretty much the ultimate services to watch every API call and every performance indicator inside of your account. So those are kind of another best practice. This is how you monitor activity. CloudTrail is arguably the most important out of those 3. CloudTrail allows you to see every single API call made against your account, particularly externally. So if you're worried about someone getting in and doing something, with CloudTrail enabled, the only API calls you should see from your personal account are from your IP address. If they're coming from somewhere else, then you know that there's probably something else going on. Like you installed Former, right? Now, one other thing to mention about roles. Roles only work on AWS infrastructure. So if you're trying to create a role for an application in your data center, you can't do that. You actually have to create a user, create an access and secret key for that application, and then give that application access. Now, if that application, by the way, federates with another system like Active Directory, you could actually give it Active Directory, like you could put a role on the Active Directory system. But for the most part, you cannot put a role on an externalized app that's outside of AWS. You have to give it a username and password kind of combination instead of a role. So that leads to our knowledge check. You have a web application on an EC2 instance that requires AWS credentials and authorization to use AWS services. Which of the 4 entities should you use? Do you use users, groups, roles, or MFA?
Charlie.
Sorry, say that again.
I said Charlie.
Charlie, roles, right? You use a role for that. If it's on AWS, use a role if you want to grant an application running on like a application hosting, like a virtual machine or a container or whatnot, give it a role. That way the role will get permissions. If it's outside of AWS, then you have to use a user. So let's see what AWS says. That's right, strike out MFA. MFA is not even a thing. All right, questions about anything related to IAM?
You talk at a little bit more length. I recognize this is just kind of a survey course, but about the ways that Identity Federation works with AWS and like at an enterprise scale for like large customers who want to take their existing IDAM practices for their enterprise, largely built around AD. Like how do you connect that into AWS in meaningful ways, and what's the shape of that big structure?
Yeah. So in general, what happens is that what will happen is that the user will first actually log into the system in question, and they'll get like a token or some other kind of like identifying mechanism that they've now achieved, right? The authorization that they need, right? Or maybe authentication would be a better term. Kind of get those confused. I apologize. But once you get that identifying token, what happens is then that token is then submitted over to AWS. AWS has a relationship with the provider, like here, like you see the identity providers, right, has an option, which also, by the way, will help them with single sign-on as well. But you can add identity providers. Like in this case, I actually added, in this case, it's just Kubernetes because Kubernetes doesn't recognize users. That's a long discussion. We're gonna leave that alone. But like I could add another provider here that anybody who will do OIDC or SAML, right? OpenID Connect or SAML. And once you submit that token back to AWS, AWS will verify that that's valid. And then what will happen is that you will have set up roles that are associated with groups that you have inside of your identity provider, and that will then grant you access to AWS. So there's this interplay between the external identity provider and AWS where they trust each other and they talk to each other, so that when, like, for example, a token is submitted, AWS can verify the token and then grant permissions based on whatever roles in AWS and whatever groups are set up on the other side. So it can be a fairly automated process, depending on the level of and granularity that you're trying to like create as far as control. But those are the broad strokes. The details around those levels of implementations can get very, very granular, because you might only want to restrict people to the projects they're working on. The security team might have read-only access across all accounts. Operations might be limited to only creating infrastructure. Like there's tons of subtleties there, but that's the broad strokes, is that you connect AWS's identity provider system with another identity provider system. And if it's like Active Directory, you just create a two-way trust between AWS's Active Directory structure and the on-premise one.
Would the details be configured essentially by marrying AWS IAM roles with Active Directory, like groups?
Groups. Yep. Yeah. Okay. That's exactly what I was just indicating. The roles map over to groups.
Okay. Cool. Thanks.
Yeah. I don't have a more simple answer, so I hope it will suffice, because it's a really complex question, unfortunately. Okay, so threat assessment, because we're now on to security and compliance. Let's see. Challenges of threat assessment. I don't necessarily agree with some of this, by the way. I think valuable. It's very valuable. I think it can be time consuming. It can be complex. It can be difficult to track IT changes. But that doesn't necessarily change just because you go to cloud. But these are some of the traditional challenges that you see. So Amazon has a tool, one of many tools, called Inspector, that basically does a network and a host security assessment, especially if you put the agent in there, that will produce a detailed list of security findings. It'll find things like, hey, you're not following, there's a common CV going on at a high, it's a high risk CV. There's a problem with your authentication best practices, you're violating network security, et cetera, et cetera. And it will put all your findings and rank them. And it'll not only show up here, by the way, they'll also show up on what's called Security Hub, which is where all the security services can centralize their findings. But Amazon Inspector works primarily on EC2 instances and their operating systems. Now, if it finds a violation, it'll say, hey, look, like you're allowing root credentials to log in over SSH. It's going to be a problem because you're losing password and you're allowing root over SSH. And, that's going to be an issue because someone could potentially brute force unless you've got mitigation techniques for that. So That's Inspector, which is used to basically detect vulnerabilities from a network and host perspective against Inspector. I'm sorry, against EC2 instances. Now, what about like pure like external network attacks? Like not just stuff that's coming into your EC2 instances. What if someone's like trying to overwhelm your load balancers in your web application? Well, a distributed denial of service attack usually involves a botnet of some type that is basically, doing a variety of differently like weird things to, everything from handshakes to send floods to whatnot, right? And so distributed denial of service attacks, the idea here is they're either trying to knock you offline or they're trying to get you to spend so much money that keeping your service online is not cost feasible for the business. So mitigating it can be like complex to solve, but with every AWS account, there's a product called Shield, and it's a managed distributed denial of service protection service. It's always on. AWS's security team is constantly watching their networks. You don't even see it, and they will literally block known bad actor organizations or known good actor organizations where a host or some particular IP address starts sending malformed packets or whatever it is. Sorry, not just malformed packets, whatever the attempt is, right? And they'll allow legitimate user traffic. There's also an advanced version of Shield where I think you have to commit to it for a year, and you get a portion of a dedicated security team, and you get cost mitigation in the event that you have to spike up with your services. So there is an advanced, you do pay a little bit more, but Shield Standard is included. And so Amazon typically does an awesome job. I've only actually ever been caught in a distributed denial of service attack one time. And please laugh when I say this. It was actually self-inflicted by one of our salespeople who actually decided they were going to engage a click farm in Malaysia, which is completely unethical. And they literally crushed our infrastructure. And I was like, man, that's crazy. Why would you do that? Right. And then Amazon, who was our mainly service provider, they were like, yeah, we're going to start blocking this traffic. And I was like, please do. Right. And that was the one time I ever saw the effects of a distributed denial of service attack, like en masse, because usually we mitigate that with WAFs and other stuff. But it was the first time I've ever like lost against a distributed denial of service attack. Was one of our salespeople was engaged to click farm. Oh man.
So what was that? What was the user experience like? Did like someone from the SOC call you or send you some big urgent flashing message?
So AWS actually contacted us through our email, which we had monitored. So we always use distribution lists for our account creation. So that way it would actually go to like, all the VPs and whatnot, whoever needed to see it, operations folks. And so we got paged that there was something going on. And right as we got paged, the traffic started spiking on our monitors. So we knew almost instantly, and we had just gotten a message. I was like, hey, Amazon says that we're under attack right now from APAC. And, immediately like the alarm started going off. People were like, start going through all their stuff to mitigate and whatnot. And then I emailed them back and said, hey, we had a TAM, we had a technical account manager, emailed them back and said, hey, we need to get on the line. We called our TAM, and our TAM was like, hey, just letting you know, what do you want us to do? And I was like, can you just block it? But just to say this, we had enterprise class support, which I think most large, like Booz definitely has. So we had a dedicated technical account manager. And so that was one of the best like experiences I've ever had with AWS. If you don't have support, getting support on things like that is really tough with AWS. So typically I recommend that people either have a business or enterprise class agreement, which we'll talk about support later. But if you have an enterprise agreement with AWS, it is one of the best experiences from a service perspective that I've ever had. And I've had like IBM, I've had contracts with Google, I've had contracts with Akamai, like all kinds of people. But AWS was really spectacular. That's one thing they really do get right. So, and then they block the traffic, and then the sales guy walks over to the pit basically and was like, hey, notice we're experiencing a spike in traffic right now. It's like, I may have done something to create that. And I was like, ugh. Anyway, that had nothing to do with AWS. So, and that was 10 years ago, and that company's out of business, so I can talk about it now. So, All right. Any questions about Shield versus Shield Advanced? Okay. By the way, they didn't have Shield Advanced back then, so this was just normal response from them when I had it. So just to be clear, that wasn't an advanced experience. They didn't have Shield Advanced back in 2013, 2014 when I had that experience. So it's probably even better now, honestly. Okay, here's all the assurance programs. You can look them up in artifacts, right, which I just talked about. You can also find it on their compliance webpage, right? Remember, not all services are compliant with all things. I don't think it's not super spotty, but there are a few fringe services that maybe don't have the deepest level of HIPAA compliance. So make sure you're evaluating things on a service by service basis. Now, how does AWS help customers achieve compliance? Well, they have their programs and they will share information under NDA. So just know they're great. I've been through several audits with AWS. They're awesome about this kind of thing. They're also very strict about what it is they will and will not share, because they are not going to give away anything that will give anybody an advantage or could potentially make it public. So, and they will talk directly to your auditors, but they may not reveal information to you, but they would reveal to the auditors, right? So just FYI. Remember, you own your certification, right? So they'll be a part of it, but you can't abstract away everything. They're just going to do the stuff that they're responsible for. Anything involving your data, your configuration toggles, your operating systems, that's all going to be you. Or us, because I'm a customer too. This question. Which of the following are best practices for security? So let's see. Deleting root user access keys. Is that a best practice for security? I think we talked about that, no?
Yeah.
Right? Don't even create access keys for your root user, much less delete them, right? Use the same password for all users. We're just going to skip that one because you probably know the answer to that. You're definitely not going to use the same password for all users. Using roles for applications. Did we talk about that? Is that a security best practice?
Yeah, we did talk about.
Yeah. When you can, you should ideally assign roles for applications when you can. If it's on premise, if it's on a data center, you can't do that. What about embedding secrets in your code? We didn't really talk about that, but do you want to put sensitive information in your code?
No.
No. Matter of fact, this is why they make vaults and secrets managers, so you can put the information in them, not have it in your code. When the code boots, it goes and grabs the secret, pulls it back, and then starts, and no human being has to see it. And it's not stored anywhere, right? And then activating multi-factor authentication. I know we talked about that. MFA should be running ideally everywhere when possible. Those SKUs are a little off. Hold on, let me just take a quick note. Slide 35. All right. All right, key takeaway. Security is the highest priority at AWS. Probably, even more so, they obviously want to be profitable. That's a big part, right? But they, if by the way, if anything ever happened from a security perspective, this whole cloud game would be over. People would freak out and pull back, right? So that all the cloud providers are really doing their best to maintain high standards for security. And they've got a lot at stake, so there's a lot to make that happen. The shared responsibility model is what defines what you're responsible for, which versus what AWS is responsible for. IAM is the service to control access to AWS. Basically, not for application users, but for access to AWS services, right? And you can federate it. Inspector is a vulnerability assessment scanner for networking and OS for an EC2 instance. It will not just, by the way, just scan a network. It will scan the network of an operating system. It will not just blatantly do a network scan. It only scans in the operating system and the network of an EC2 instance for vulnerabilities. Just to make sure I was clear on that. And then AWS Shield, which has an advanced version and a standard version, is used to protect against distributed denial of service attacks. And AWS has a number of compliance and security programs. They will work with your auditors. And you can find everything that you need documentation-wise in what service inside the console? Someone tell me, remember the name of that service that we looked at? Ooh, it's artifact. Make sure I type that in there. Maybe I didn't give you enough visuals for that. Artifact is the service inside of your AWS account that allows you to download all the attestations that you need. All right. That covered everything related to security. Let's talk about pricing and support. We do have a third lab. It's on Trusted Advisor. It's a really quick lab. So, we will actually do that lab. And let me just go ahead and pre-warm it just to make sure we're all good here. Trusted Advisor tends to go pretty quickly. So just, we'll definitely run that one down. What we'll do is we'll go through this module, actually do the last lab, and then we'll end with a discussion around support and then training. This pricing model one, just so you're aware, can be really complicated. There is a pricing overview kind of white paper for AWS. I highly recommend that people read it, and I actually will show it to you when we go over the Cloud Practitioner ramp up guide. So I just want to make sure that you're aware. We are going to skim this because I think it was, oh God, it was Andrew earlier kind of alluded to. This is kind of a survey course, right? So make sure that if you really want to understand AWS pricing, there's a pricing guide that you want to read. All right, so let's talk about the fundamentals of pricing because I want to make sure you have some good tools to figure this out. So first of all, it's pay as you go. You can save if you decide to get into a relationship with Amazon. Now, what does that mean exactly? It means that you can commit to using services to pay for them for a year or 3 years, and Amazon will give you, upwards of 75% off depending on how much money you pay up front, but at least 10, 20, 30% off easily just by saying that you'll use a service for a year. You might say, well, Michael, what if I don't know what's going to happen? No one knows what's going to happen in a year. But you know what I can tell you for a fact? It's really hard for most of us to move our services off of where they're at onto another location. So typically, people are like, I don't know if we might migrate in a year. It's like, oh no, we're not migrating in a year. 18 months, maybe 2 years, probably, but definitely not a year, right? So just know that you can actually get into a committed relationship where you say, look, I will pay 24/7 for this service for a year. And in exchange, you're going to lower the hourly price to, 7/10 of what it was. You're going to knock 30% off. Also note that you can actually pay less. Oops, let me click that. You can pay less per unit by using more. Be careful with that. But like if you use like the first like 100 gigabytes of S3 storage costs like a certain percentage. When you go to the next tier, it's less per gigabyte. But that's not something that I find very compelling, right? If I need, a petabyte of S3 storage, I'll use it. I'm not going to go for it because I want cost savings, right? Now you only pay for what you use. So if you want to start a huge project and then drop it, you can do that, right? You can save if you decide for like on EC2 instances, like I said, if you decide to commit to reservations. There are a couple of different flavors of reservations. There are scheduled reservations, there's standard reservations, there's convertible reservations. Just know that every single reservation is going to save you money. So if you know you're going to be running a virtual machine for a long time, then just commit to having that virtual machine and you're going to save some money. By the way, most people don't know this, but there's reservations for CloudFront, there's reservations for DynamoDB, there's reservations for RDS. So talk to your AWS account manager if you're running a project that's going to last a year or 3 years, and see if you can find out what reservations are available for your project, for your architecture, because you could save your project a tremendous amount of money. There are, I mentioned before, volume-based discounts. The more you use, cheaper per unit. But again, I wouldn't focus on those. Here's some pricing concepts. Basically, when you use compute, like EC2 or containers or serverless, you get charged by the hour or second. And you're going to get your charge is going to vary by the size of system that you're provisioning. Storage is typically only going to charge you by per gigabyte and the region rights. So for example, if you ask for S3 storage and you get a terabyte, but you do 1 million puts and 1 million gets a month, that's going to cost you more than a terabyte of 1,000 puts and 1,000 gets a month, right? The other thing to consider is that Amazon will allow you to put inbound data. You can put data in AWS all day long. They will charge you nothing. But the minute you start pulling data out, they're going to charge you like 0.000 something per gigabyte. And you might think, well, Michael, that's like 1/100,000th of a penny. Who cares? Yeah, you'll care when it starts to getting to petabytes of information being transferred, and all of a sudden you're like, hey, I've got a $10,000 bill for data charges. How did that happen? Just something to pay attention to. Now, different services are priced differently. So what if you're like, Michael, I need to do some forecasting. How do I figure out what this is? Okay, so here's my suggestion. If you type in AWS simple calculator or simple monthly calculator into your web browser, and don't worry about that deprecation notice. It's been there for years. Amazon doesn't know when they're going to retire the calculator, and there's actually 2. So this calculator will allow you to choose your region. So let's say we choose Oregon. And you can come in here and add an EC2 instance. Now notice I chose a T3 2X large. What if I wanted something else? What if I wanted a T3? Let's pick something. Scroll all the way down to T3. La 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 la. What if I wanted a T3 small, for example, a 2x2, right? And so I switched that to a T3 small. I'll make this a little bigger. Notice that monthly cost is $15.23, but I don't have any storage. Where's my disks? I don't have any disks. So let's say I add a general purpose volume and I'm going to make it 100 gigabytes in size. I'm not going to take any snapshots of it, and I just want one. And guess what? My bill went up to $22. But then I'm like, you know what? I need a DynamoDB database, and my DynamoDB database is going to hold a gig of data. Average on size is going to be about 2K. I'm going to make it eventually consistent, and I'm going to have about 1 million reads and writes a month, right? Well, now my bill just went up by $2 and something cents, right? So then I'm like, well, you know what? I also need CloudWatch, so I need some monitoring. So I'm going to create a dashboard, and I'm going to have like maybe 5 custom events that I'm going to respond to, and I've got 10 alarms. My point to all this is I think you get the idea, right? Is that you can create your own estimates, right, of things that you need. Now, notice, by the way, I didn't actually increase anything with CloudWatch because I'm actually still in the free tier of CloudWatch. Notice also that I don't have any support, right? But over here are all your services. Not every service that Amazon has is listed here, because Amazon has other calculators. There's a new calculator called calculator.aws, which also doesn't have all the feature parity of the other service. So I'm going to post this in the chat as well, so please capture that. But this allows you to create estimates where you can basically say, hey, I want to create an estimate on an EC2 service. So I'm going to come in here and I'm going to configure Linux 4x16 system. Oh, wow, that's a T4G extra large. That's pretty sizable. And let's say I like this, and so I'm going to add this to my estimate. And that's $700 a month. Or sorry, 12 months. It's $64 in change a month. So this is calculator.aws. So this is another way for you to calculate costs. I would say that calculator.aws is quickly becoming the best way. But if you need quick, then the simple monthly calculator is way better. Notice, by the way, you can change the number of hours per month, depending on how you calculate that. Okay. So simple monthly calculator and AWS.calculator are the best tools you can use for pricing. Any questions on any of that?
Is there a way to estimate the cost of an EC2 instance that's going to have very low uptime?
very low utilization.
Well, you don't pay, you pay for what you provision, not for what you're using.
Hmm.
So if you ask for a 2x16 instance, you're going to pay for a 2x16 instance as if it was running at 100%.
So why does the hours per month matter at all then?
Well, because if it's February, you're going to have the lowest bill of the year, right? Because you've only got 28 days,
Sure.
right? So that has gotten us several times in billing where I'm like, wow, we did amazing in February. Well, it's because you lost 3 days, right, compared to your normal thing. So yeah, that's why the hours per month matter.
Gotcha. Thanks.
Yeah. Okay. Now, EC2 has on-demand instances, which is what most of us do. We actually pay for it and then give it back. There's no contract to use on-demand. On-demand requires a credit card. You pay per hour per second. You give it back when you're done. It's easy. Reserve instances are a commitment that you make for a year or 3 years. You cannot give those back, although you can sell your reservations on the reservation marketplace. You usually won't get your full dollar, but you'll get some measure back, right? And so you can actually reserve instances for 1 or 3 years, not 1, 2, 3 years. It's 1 or 3 years, right? So you can actually commit to pay for that instance for a full year or a full 3 years. This is for applications you want to run 24/7. You can also do the most expensive thing in AWS and ask for either a dedicated host or a dedicated instance. A dedicated host is where you've asked for a physical host to run all your virtual machines, and you pay a lot for that, and that's very custom. That they do not publish pricing for that. You have to talk to your rep. Although I think you can just kind of randomly buy it and just see what price it lands at. I wouldn't do that. I'd talk to your representative if you need a dedicated host. And the last way is spot instances, where you basically tell Amazon, look, if you've got extra capacity, I would like to buy your extra capacity. And Amazon might say, hey, look, normally these EC2 instances cost you $1 because that's the on-demand price. And you put in a bid and say, look, I'll pay you 75 cents for these instances. And Amazon's utilization goes so low that they're below 75 cents for those particular instance types, they will give them to you. They will give them to you until somebody outbids you, or their utilization goes so high that they actually need those instances back. So spot instances are great if you want to supplement on-demand instances or reserved instances, or if you're doing kind of asynchronous batch processing and you don't have a very tight time frame. Because spot instances will typically run for an hour, and then you get a 2-minute warning and the instance will be pulled out from underneath you. It will shut down. So this is great with applications that have very flexible start and end times and who write data fairly consistently out as a checkpoint. So spot instances used to be really hard. They're now really easy. They still require you to understand that your application is going to get interrupted. So if you're writing data to an external data store, awesome. If you're writing data locally on your app, not awesome for Spot. Spot's not going to support that because you're going to lose that data when that instance crashes. So on-demand, reserve instances, dedicated hosts, and Spot instances. Dedicated host is the most expensive. On-demand is the second most expensive, but also the most flexible. Spot instances are the cheapest, but they also come with that interruption process that can happen. Reserve instances guarantee capacity. They also guarantee discounts and are probably can be the second cheapest way that you can get access to AWS. Any questions about these 4 different ways that you can purchase EC2 instances? Okay. Chime in at any time. EBS, by the way, doesn't have a special pricing model, so I'm not even sure why it's listed here. EBS, by the way, charges you by the gigabytes, and they vary by the performance characteristics of the volume you've asked for. You can snapshot them. Snapshots are stored in S3. They're super cheap. You can copy those snapshots over to other volumes. and then of course data transfer is just a networking component. You have to worry about data being pulled out of AWS, not when you put data in. So I'm not sure why this is called the EBS pricing model, because data transfer doesn't apply. S3 will also determine on the amount of data that you've stored. The region will also have some variation, but the storage class, if you choose hot storage, that's going to be 10 times as much as the coldest storage that you could get. So just be aware. And if you make a lot of modifications to the storage, those get put, copy, update requests, those are going to increase your cost a little bit as well. But the biggest cost factor is the amount of storage that you're using and the storage class. If it's standard S3, that's the most expensive. If it's Glacier, especially deep dive, it's going to be the cheapest. VPCs, auto scaling, cloud formation, IAM, Beanstalk, any of the wizards or the things that actually start resources, they're not going to cost you anything. Now, the resources that Beanstalk and CloudFormation start, those will cost you something. But actually using CloudFormation itself and Beanstalk itself, that's not going to cost you anything. It's going to be easy. Now, I already talked a little bit about some estimation tools. Just know that the free tier is when you create your first AWS account. For a year, some stuff is free, and for in perpetuity thereafter, some things are free. Other things are free. So let's talk about the AWS free tier. So if we go look at the AWS free tier, this is a cool little website that they created that you can actually see all the free stuff you get. Some of this is always free, like DynamoDB, Lambda, SNS, CloudWatch. Some of this is always free. Other pieces are only free for the first 12 months after the account is created. Like you get a free EC2 instance, you get a free RDS instance, you get 5 gigabytes for 12 months for free. You can use API Gateway for 1 million calls per month. EFS is free for like this is cool stuff that actually is free for like the first 12 months. After that, you need to go create a new account or just delete whatever you've created, right? But it's pretty cool. Like there are some things that are always free in AWS, at least up to this level, right? So that's what happens if you create a free account. The other thing to note is that we talked about the simple monthly calculator, which will allow you to estimate your bill. But I just want to be clear, the only real way to get accurate cost is to run the workload for a period of time under like load and see what it does. Because you might need to add instances, you won't be able to predict network traffic, you won't know the number of changes that are made to your database per se. So simple monthly calculator and the other one is the calculator.aws are absolutely awesome. One other thing to mention is that when you're in your account, if you click on your name, your IAM name, there's a section under here called your billing dashboard. If you click your billing dashboard, this will give you so many tools to see what you're spending in your account. It's really awesome, including this little thing called Cost Explorer, which if you click on Cost Explorer, it's going to ask you, typically it will ask you questions. I guess mine's not today for some reason. And this is going to actually show you the breakdown of things that you have spent over time. So like every day I can see that I spent $26 on this day. And on other days, it looks like I spent $5 and spent a couple bucks here. And then all of a sudden I just dropped everything down, which I think is probably pretty accurate. And by the way, using this data, they will try and forecast what your spend is going to be for the month, right? So notice that it's forecasting I'm going to spend $5.73 total, right? It noticed that Virginia costs are up by 21%, right? Because usually I spend 4 cents a month. So just know that there's a number of tools, including setting budget, notifications. I just want to say that they just added a thing that allows you to stop instances if you cross these thresholds. They just did this. It's only been here for maybe a month. Before, these were just notification budgets. Now they're actually limits. You can actually turn off stuff in response to you crossing your budget limits. So if you are opening your free account one of the first things you ideally will do is come in here and learn how budgets work, because budgets will allow you to stop things from charging if you don't want them to. Like you can see my limits here is that I have $15 for DNS, $100 for overall, $15 for data stores, 12 for containers, so on and so forth. Notice I have $30 allocated for my EC2 budget. I can actually come in here and set these up as limits and say, look, if if my EC2 budget goes across $30, I want you to stop every single EC2 instance, right? So you can do stuff like that. I haven't done the new limits yet, but this is something they just did inside of AWS for budget controls, right? So I'm excited to see this, because this has caused a lot of headache with people who have mistakenly not turned off services that they should have. So that was Cost Explorer with budgets, which we just talked about. You can filter and group data. You can do all kinds of stuff. Just one more kind of plug for Cost Explorer. The Cost Explorer, for example, will give you a breakdown by service as well. I will tell you, just for everybody here, if you're ever running your own thing and you're like, why is this thing charging me? Cost Explorer will actually show you by month, by service, what you're being charged for. You can also just go into your billing dashboard and click on your bill, and your bill will tell you exactly where you are incurring charges. So notice that I could be incurring charges in Ohio and Virginia, but I'm actually not, because it's not hitting the threshold. If I was worried about data transfer, I can actually go down here and look at data transfer across everything from Ohio to Virginia, right? Although look at all this stuff coming from Tokyo and Seoul and Osaka. What is all this? I don't remember setting anything up for this. Interesting, right? But my point being is that this is the bill section under your billing platform. If you go over here, over to my billing dashboard, this is bills. Bills will tell you exactly what you're spending where. This is the number one question that people throw out that they don't know how to answer, which doesn't make any sense to me, because this bill section will tell you exactly where you're spending money where. It won't tell you what, but it will tell you exactly where, in like either globally or in a region, or even in no region, for example. Like it's like, hey, oh, I got a credit. That's funny. It'll show you, like, for example, I have a database running in US East Ohio that apparently was exceeding the free tier, right? So just something to be aware of is this is how you figure out what's going on with your bill, is that you go to bills, under billing. Okay, Cost Explorer, that was bills. Let's talk about Trusted Advisor. So Trusted Advisor is interesting because it really is just an advisor along these particular pillars: cost optimization, performance, security, fault tolerance, and service limits, which service limits is probably one of the most important. But what Trusted Advisor does is it says, hey, you have a security group out there attached to an EC2 instance, and it is wide open to the world. Is that what you wanted? And so Trusted Advisor is really great because it watches your account for best practice violations. And if it's a really bad violation, it's going to throw it into a high. If it's like, just a caution, it'll throw it into a medium. If there's no violations and everything looks good, you're like following best practice, it'll throw it into a green. Here is an example. I hope I didn't disable Trusted Advisor. Hold on. Here's an example. Okay. So by the way, unless you're paying for support, you don't get access to everything to Trusted Advisor. Trusted Advisor only works for people who have a business or an enterprise level support plan. I think I have a developer support plan, which is why mine is so low, right? Just FYI. So like here, by the way, it's saying, hey, you've got a security group here where it's got unrestricted access to like a couple ports, right? And so in this particular case, it's saying, hey, you've got a couple of 0.0 to specific ports. Is that what you wanted? So you might want to check that and see what's going on. Otherwise, notice that it's giving me great on service limits. There's no issues here. I don't have any issues with service limits. And from a security standpoint, it says, hey, I got no public snapshots. My bucket permissions are awesome. IAM use is good. I've got MFA on my root account, right? Notice it says here, upgrade your support plan to unlock all of the recommendations. Be mindful that this won't work for you unless you actually have a business or enterprise support plan with AWS. Just FYI. Okay, quick knowledge check. Now that you've started your migration to the cloud, you want to find out which service you use the most and where the majority of your traffic is coming from. Which tools should you use if you want to explore your service usage and where the majority of your traffic is coming from?
Rob?
That's right, Cost Explorer. Cost Explorer is the only one that's going to give you a reporting. The free tier is just something you get for your account, right? Simple monthly calculator, and I don't think there is an annual calculator. There could be. I haven't seen one. Those are just services that allow you to calculate costs. Cost Explorer is the only reporting service. Okay. We're on to support, and then we're going to take a little break. Well, we're actually going to do a lab and take a break combination. Okay. So basic support is what every account gets, which is basically nothing. I mean, you get access to all the stuff everybody, like you get email support, or you get forum support, but you don't really get anything else. Developer is the next tier. You get everything from the above tier above it, and you get some best practice guidance, but you really don't really have a whole lot of support with developer. By the way, I think developer costs you $50 a month or some percentage of your spend, whichever is greater. Then there's the next tier, and you've gone from practically no support to business class support. They will respond, I want to say, in like an hour for your production critical systems, which may not be good enough for you. And if it's not, then you have to go to enterprise support, which then will respond in 15 minutes or less, right? But business class support will give you an API for interacting with the support center. You get access to Trusted Advisor. You get third-party software support, use case guidance. You get everything. It's awesome. But it is a percentage of your monthly spend with AWS. Enterprise support is more like an enterprise agreement, a higher percentage of spend with your AWS account. And you get a TAM, Technical Account Manager. I've had this twice, maybe 3 times with AWS, and every time it's been amazing. It's been a great investment. You get case routing, you get to talk to product teams. They'll come on site and do trainings and all kinds of stuff. You can throw your application architecture at them and they'll respond. So being part of Booz, I'd be shocked if you didn't have an enterprise agreement. I'm pretty sure you do. And they will conduct regular business reviews with you as well. So enterprise support is just spectacular. Again, having had like Google and IBM and Akamai, I just have to say that it's really good. Now, notice the response times. With basic, it's basically no response time. With developer, it's usually 12 hours. And by the way, it's going to happen through email, not a phone call. With business, you get email, chat, and phone, and they'll respond to a production system down in an hour, right? If it's degraded, it might be 4 hours. With enterprise support, you get everything that you got before, but you get senior cloud support engineers and you get a critical system downtime of 15 minutes. So you get a much better response time. Plus you have a TAM. The TAM will usually call you before you even know there's a problem if you use enterprise support, which is really nice. Remember that you need business and enterprise support to get access to all of the Trusted Advisor checks. I wouldn't pay for it for that part alone, just so you know. AWS, by the way, has tons of support documentation, quick start guides, lab guides. They have tons of free stuff out there. And since it's been around for 15 years, a lot of it's actually really good. Their documentation is pretty awesome. I'm not a big fan of documentation in general, but I actually like between them and Kubernetes and like Ansible, and I've read a lot of their documentations. It's good. So the key takeaways here are is that if you need information, you can find it on AWS. They have it, right? Key takeaways here is that you can do a pay-as-you-go approach for pricing. You can also, by the way, get into a relationship with Amazon and go cheaper, like get cheaper, like get discounts on pricing. They do have other versions like Spot and Demand, dedicated host, which are more expensive, but also in some cases cheaper, depending on your kind of application model. Spot pricing can be awesome. By the way, most people buy dedicated hosts or dedicated instances when they have a security or licensing restriction that needs to isolate them from the rest of the environment. All the services have different pricing factors, but they're generally about like capacity and action dimensions. Like how many gigabytes did you ask for? How many changes are you making per month? There's the simple monthly calculator and calculator.aws, which both will help you estimate your bills. And then Trusted Advisor, along with a support plan, will give you best practice guidance against your system as well as better response times. And if you're looking for more information, there is tons of AWS information. The AWS docs, I have to say, are pretty good. And by the way, you can get them on your Kindle. Like if you have a Kindle or the Kindle app on your phone, you can actually get them on your Kindle. So like if you wanted more about S3, you can actually go to Kindle and get, for example, like the developer guide. Or if you want to see it on GitHub, you can do that as well. Or you can just download a PDF. But all of the references for all the different sections are listed here. So if you needed to know more about compute and you wanted to know more about EC2, by the way, look at all this. You can actually get a lot of these on Kindle, right? Auto scaling on Kindle. So just know there's really great documentation out here. By the way, if you want other related links like white papers and whatnot, you may have heard me mention before, I was talking about pricing. There is a pricing paper about how pricing works on AWS. Definitely worth the read if you need to know more about it. Put that in chat just in case. So then we're on to lab 3. Before we do that, questions, curiosities.
There was a slide a while ago that had was about reservations. It Nuri, Puri, and Auri or something like that. Can you explain the difference between that?
Yeah, so let's say that you want to reserve like a 2x4, 2 processor, 4 gig system. And normally it would cost you $1. I'm gonna make this up, right? $1 an hour if you're using on demand. You go to Amazon and say, look, Amazon, normally that $1 an hour instance would cost me $730 a month. Let's just take a swag, multiply that times 12, and it's going to cost me, $9,000 a year. And I want it for 3 years. And if I paid on demand price, it would cost me $27,000. So $27,000 for this instance, right, would be the normal math if you were to pay on demand pricing for 3 years, right? $27,000 for 3 years. You could go back to Amazon and say, look, Amazon, I'm not paying $9,000 a year for 3 years. So if I give you $5,000 now, how much will how much will you discount the price, right? And so what they'll do is then they'll discount the hourly price. So that instead of paying $27,000 over 3 years, if you gave it $9,000, they would then say, well, normally you'd pay $18,000, but instead we're going to knock 50% off, and you're going to pay $9,000 for the remaining 2 years, like for the entire 3 years. So you've given Amazon $9,000, and you're now like $18,000 would be your normal price, but they've knocked 50% off. So you just knocked off a third off the cost because you paid some version of money upfront. That's what the no upfront, which is what the NURI is, partial upfront, and all upfront is. That means that if you pay it, for example, all upfront, let's say it's like Amazon normally this is going to cost $27,000. I will pay you I'll give you half of that, right? So I'll give you a 13.5, and then what will happen is they might steeply discount the price up to 75% off the hourly if you pay more upfront versus partial upfront versus no upfront. So that's what Nuri, Puri, and Hourly means. Is it means that did you pay a lot upfront? Did you pay some upfront, or did you pay nothing upfront? You still get a discount off the hourly price, but the discount is deeper if you give Amazon money now versus paying over time.
I see.
Yeah. So of course, the more money that you get now, that you give Amazon now, the deeper the discount. So Ari is the most expensive from an outlay perspective, but it's the cheapest hourly. That's all upfront. That's what that stands for.
Do you know what the RI is? It's bugging me.
Reserved instance, all upfront, reserved instance,
Gotcha.
partial upfront, reserved instance, nothing upfront, reserved instance. That's what those stand for.
Fair. Thank you.
Yeah, it's a good question. Most of the time when I have to walk into the CFO's office or the CTO's office and be like, hey, do you want some discounts with AWS? And they're like, sure. And I'm like, okay, well, here's the deal. If you give me $13,000 right now, I'll get you a 75% discount. If you give me nothing, I'll give you a 20% discount. What do you think the CTO always says to me every single time? No matter how favorable the math is.
No money now.
That's right. Every single time, no matter how compelling the value is of, hey, let's go ahead and give them $100,000 and we'll save over 3 years, like 200, that not one time in the last 11 years that I've been working cloud has any CTO or CFO gone for the long-term savings. Even though the CFOs are always like, man, that is a compelling amount of savings. We're not going to pay. We're not going to put that much money out. We got into cloud so we wouldn't have to do large capital outlay, right? Because if we're going to do that, we might as well go back to data centers, right? That's usually what people say to me. So no upfront is what 99% of the people I encounter do. All right. Let's do our last lab of the day. And then, oh man, our timing is perfect. Then we got 30 minutes to talk about something. I don't even remember what. We can talk about our last thing, and then we're done for the day. And so I might even have you out here on time, oddly enough. Okay, so lab 3 is basically, we're going to do Trusted Advisor. I believe that I pre-warmed the labs, at least in my mind I did. Yep, I did. And so the labs are pre-warmed and ready to go, so go ahead and pop into them. This lab is really straightforward. You're really just going to actually like check some actions with Trusted Advisor. You're going to force some like bad practices and then enable some good practices. And then that's it. Lab is really straightforward. Typical duration for this lab is 30 minutes. So it's 3:30. Let's go ahead and roll into it. I'm actually going to step away for just like 5 minutes. I would absolutely recommend at some point in time that you do the same, take a bio break or whatnot before we hit the last 30 minutes. But go ahead and start the lab and let's get cracking. So I'm going to step away for just 5 minutes. I'll be right back. All right, everyone, just checking in because I had to step away for a second. Everyone's lab start smoothly. Everyone doing well?
Gravy.
Okay.
Michael?
Yes, hi.
Yes, I've only got 2 of the green check marks. Nothing, everything else is a question mark. I think it's something that's supposed to be critical.
Hmm.
All right, it finally refreshed. I'm not sure. All right, because I hit refresh a few times, but I guess I finally caught it now.
Okay,
All right.
good. Start recording, share my screen. There we go. Oh, that's not what I wanted. Let's do that. Okay, so the last little piece. So we basically spent, you know, 6.5 hours today going through all the different services that AWS has. So the last piece that we're going to talk about is just how AWS typically approaches architecture. This is just something for you to keep in your back pocket. If you are doing in the architecture class, you dive into this into a lot more detail. Actually, you dive into this if you do system operations to a certain degree as well. So let's talk about some architecture recommendations. So we want to talk about the well-architected framework, let you know about some of the reference architectures out there. And, you know, AWS has a particular like future of cloud that's very short that they want to talk about. The main thing to know, by the way, is that the author for the well-architected framework, which this completely cracks me up, is the same guy who did the well-architected framework for Azure. He actually left AWS, went over to Microsoft, and pretty much wrote the same thing over there. So I know because I have friends who work at both companies, and it was quite a source of hilarity when I got them all on the call, and they were joking about this guy having wrote the well-architected framework. So here's the cool thing. If you learn the well-architected framework for AWS, apparently you get it for Azure as well. So let's talk about the well-architected framework. So this is a filtering guide for how to approach designing infrastructures on AWS. So it's a bunch of best practices that are typically affiliated through experience that they've gained through the years working with customers. There are 5 pillars. They're usually not put in this order, but it's usually operational excellence, security, reliability, performance efficiency, and cost optimization. Operational excellence, by the way, was just added in the last few years. It used to just be the other 4 pillars because of the need for operational rigor, right, and consistency when it comes to operations. So operational excellence, this particular aspect of the 5 pillars of the well-architected framework is all about you know, learning from failure, making sure that operations is performed as a code function and not as like a manual kind of click, click, click function, so no click provisioning, making sure your batch sizes are small, and making sure that you are constantly improving and refining the relevant procedures for operations. It also speaks strongly to not trying to avoid failure, but to anticipate failure. The second pillar, security, talks about, you know, observability and traceability at all layers, so applying security itself at all layers, how to automate responses for security best practices, including prevention, right, and detection, and then making sure you're protecting data in transit and at rest, and having a strong foundation and preparation for security events as they arise. Reliability is about basically having recovery procedures, making sure that you're right sizing capacity or making your capacity elastic, right? So a lot of good automation that's usually predicated on data. You know, making sure that your systems are self-healing and auto-recovering, and focusing on horizontal scalability to increase the overall system capability. And of course, managing change and automation, because then you can get the best of software engineering disciplines such as, you know, testing and peer review, that kind of thing. So operational excellence, security, reliability, and now we're doing performance efficiency. Performance efficiency is how do we make hard technologies easy to consume, right? How do we go from more abstracted services that let us focus on our core business value? How do we innovate more often? And applying mechanical sympathy is interesting because, you know, even when I first heard the term, I didn't know what mechanical sympathy was. It basically is, it's use the system for what it's designed for. Like you wouldn't use a screwdriver as a hammer, and you wouldn't use a hammer as a screwdriver. So make sure that you're using the system or service for what it's designed for and optimizing for that function. And last but not least, but basically make sure you're watching and analyzing your spend on a regular basis. Try to be adept and skilled at knowing what will cost you money and what won't, and how do you optimize for certain models of consumption. And of course, you know, stop spending on data center operations. It's kind of like AWS's mantra because that's the business they're in. But they also talk about how you can reduce soft costs by using managed services and get more abstraction away from things like failed hard drives, failed network switches, operating systems that are out of date that need to be patched. So those are other aspects of cost optimization. So the 5 pillars are operational excellence, security, reliability, performance efficiency, and cost optimizations. There is a whole section of their website dedicated to the well-architected framework, and there are papers written for each of these sections if you want to dive into them in detail. Now, that being said, there are tons of reference architectures at AWS. Let me actually pull some up here. Sorry, excuse me. For example, here is a couple of reference architectures. Notice that immediately it gives you references to the well-architected framework, but you can get technology categories on everything from data analytics to core computing or whatnot. So this is a great link to have if you're looking for reference architectures, right? There's also, by the way, for example, this is one that shows like improving availability with elastic load balancing, right? And replicated data between databases. Here's a web application example architecture, right? That shows offloading resources to S3, elastic load balancing both the web servers and the app servers, right? Those are some of the reference architectures that are actually in the set. Notice here that RDS is doing replication. They've got auto scaling in play. They've got a bunch of cool things at play. There's also quick starts. Quick start guides are basically automated gold standard deployments in AWS. These are fun as well. I'm actually going to give you the short link, not the long link. But you can come in here and say, look, what if you wanted to deploy Kubernetes? Because you hear everybody's talking about it. I'm kind of curious. You actually just search for Kubernetes, and guess what? You get not only Rancher and Snyk and Boomi and all those guys, but you'll actually also get, and OpenShift, which is very popular. But you get AWS's reference guide for EKS architecture as well. Word of caution, if it's like a little older than 2 years, it needs to be updated, so I'd be cautious. But anyone that's 2 years or less is totally great to go, good to go. Here, by the way, they're using federated Kubernetes clusters using AKS and kubefed. By the way, OpenShift is a first-class citizen on AWS. I think Azure and about to be Google. So if you're wanting to use OpenShift, which is basically like Kubernetes plus, it's like way more than Kubernetes. Know that that's an option. But these quick starts are basically allow you to find technologies that you're interested in. Oh, and by the way, when you go into the quick start, let's pick EKS as an example. You can actually view the guide in question, and notice that it will allow you to deploy directly onto AWS. So once you actually read the guide and get an understanding, you can literally launch the quick start into an existing VPC, and that thing can get up. It says 25 to 90 minutes, you can have your own EKS cluster up and running. So those are quick starts. I passed those up already. So those also have CloudFormation templates built by architects. It's a guide with deployment instructions. Really awesome. Here's a couple others before we get into knowledge check.
Michael,
Here, oh, sorry, go ahead.
what would you say is the main set of differences between these quick starts and Beanstalk? Is it just they cover different things, or?
Beanstalk is only going to deploy basically either a web or a worker app onto an EC2 instance. So the Beanstalk is very limited in its flexibility. So while Beanstalk will best practice you with EC2 instances, and so therefore will cover like a different set of use cases than the use cases you would say on a quick start. Quick start is going to cover a much broader set of technology, right? So whereas Beanstalk is only going to be limited to EC2 instances and possibly RDS.
Okay, thanks.
Yeah. So yeah, and it's only going to do a web app or a worker app. That's it. Whereas this could be anything from mobile, which I'm kind of curious as to what's in the mobile section. Performance dashboarding, pinpoint, real-time sports using AppSync, which is a service, IoT device simulator. Like none of this will exist inside of Beanstalk. So in addition to quick starts, in addition to the reference guides, let's go ahead and slow them down. There's also the Amazon Builder library, right? It's kind of confusing, but this is like architectural things to know. It's not really like deployment per se, but it's like if you want to know more about how to do reliability inside of AWS, including services that might be applicable, these are little like snippets, if you will, of like either architecture or software delivery and operations that will give you deeper insight in concepts to consider and think about when deploying on AWS. So if you get a custom solution and you're like, hey, I need to know more about automating safe hands-off deployments, like they're little concepts that you can study as well. The other thing that I wanted to mention is that AWS Labs is probably the most popular GitHub repository out there for and by AWS. And it contains things like how to extend your Git hooks so they'll scan for secrets. They've got the CloudFormation templates in here as well. There's all kinds of incredibly cool stuff. How to create a service workbench in AWS. How do you, do Node.js bindings? Create your own custom CloudFormation monitors, drivers for different things, for like QLDB for Python. There's like some cool stuff out here. This is more like a messing around, playing around. But like if you're looking for CloudFormation, they have the core templates out here. There's also like there's a Go library for CloudFormation templates. There's all kinds of stuff. It's really kind of amazing, right? Tools for converting CloudFormations between JSON and YAML, right? So AWS Labs is the other place if you're looking for a really like a technical tool or some kind of like templates or whatnot. The labs, AWS Labs is probably one of the best places to go. Last thing in terms of resources, probably the most significant for Booz Allen Hamilton employees. This is amazon.quicklabs.com. This is not webage.quicklabs.com. This is a totally different website. I am logged in as a totally different user over here. I'm actually logged in as my personal profile. And if you go to the catalog here at amazon.quicklabs.com and you click on Hands-on Labs and you type in introduction, this will allow you to find the free labs that Quick Labs has for everything from CloudFront to Lambda to DynamoDB. So if you want the same hands-on experience that you just got with DynamoDB, you just hit Start Lab when you're signed in. Guess what? You can go in and do the DynamoDB lab for free. Here's the cool thing about working for Booz Allen. Booz Allen, in relationship with Web8 Solutions, actually gives you free credits so that if you create an account using your Booz Allen Hamilton email address and you put it into amazon.quicklabs.com, you will get a bucket of credits. And I can't show you because I'm not actually a Booz Allen employee, but there's a bucket of credits that will show up under your profile, and you can come out here and run any of the labs that cost a credit, 8 credits, 5 credits, 10 credits. In other words, you could go to the advanced and fundamental labs. If you wanted to run this 10 credit lab, which normally costs you $10, as a Booz Allen Hamilton employee, you get to run this for free. So if you come out here and create a free account on amazon.quicklabs.com, when I just posted, using your Booz Allen Hamilton email address, the bh.com email address, you will get access to a free credits that are free just for your company. Questions about that? No? Okay. All right. Let's finish this last little piece. There we go. Do quick starts. Okay. Question. Which of the following is not a pillar of the AWS Full Architecture Framework? Is it security, persistence, cost optimization, or operational excellence?
Bravo.
Yeah, definitely Bravo. Definitely persistence. Persistence is not always desired, at least not for every application. But what are the missing pillars here? So we've got security, cost optimization, operational excellence. What are the missing pillars? There's two. Performance efficiency is one. What's the other one that's missing out of security, cost optimization, and operational excellence? Sorry, someone would put it. Sukwani, yes, reliability. Reliability is what's missing. Good, okay. All right. So key takeaways is that there's a well-architected framework that has 5 pillars that Amazon uses to help kind of filter decision-making inside of AWS. There are a number of resources, everything from the builder library to quick starts to reference architectures to the AWS labs. There's tons of resources out there for AWS. So if you're looking for cloud formation or concepts, or there's a whole section on white papers, you can find them out there pretty easily. The last thing is that AWS, talks about how basically IoT and really specific purpose-built serverless and services, along with serverless, for them is the future of cloud computing. We're finding more and more people don't want to host infrastructure. Right now we're seeing a tipping point where there are now more containers and serverless deployed than there are virtual machines for applications out there in the wild, at least for those who report. Who knows the truth of that, right? And more adoption towards low code and no code kind of setups where there's already no servers, but then they're moving more towards a serverless no code, low code function, and where the edge, especially with 5G and then its subsequent child 6G coming out in the next couple of years, we're seeing the edge is shrinking, and so we're seeing more bandwidth available for IoT devices, and we're seeing more sophisticated IoT devices come out. So, I mean, who would have thought that we would have had a blockchain service, right, or a quantum computing service? But we do, and so you're going to see more of those kind of purpose-built services emerge over time, particularly for specific industries. We're seeing a lot of movement. I think predictive analytics and machine learning are considered kind of an afterthought now. It's expected that you will have them. Enterprise and digital transformation seem to be kind of core, along with the gamification in general of systems. And of course, robotics is taking off ridiculously, particularly with RPA. And then enterprise applications and the hosting of those is considered to be an afterthought. People are expected to either be using someone who's good at it or they're good at it already themselves, right? And that's it. That is the end finite. Does anyone have any questions about any of that? Okay. I've got one last thing for you, unless somebody has a question for me.
Maybe something kind of specific for my track, but as a going the Scrum Master route, what would you recommend as building off of the Cloud Practitioner cert to get more specialized, but going more like the PM/Scrum Master route?
So that's a good question, actually, Zachary, and that kind of tees up actually for one of the last things I was going to talk about, is that there are ramp-up guides out here that would kind of give you a guided path per role. Notice that there's architect, business, cloud practitioner, developer, and then operations, but there's also guidance on a per technology solution basis. So if you're into containers or game tech or Internet of Things, or you're interested in storage and machine learning, these guides are pretty powerful. So to answer your question, if we were to look at a guide from a business perspective, these guides actually include incredible free resources to become very familiar with cloud in general, right? And so here you've got the fundamentals of cloud, including 10 considerations, a white paper on 10 considerations for cloud procurement. Practitioner Essentials, which you're actually taking today. Just know, by the way, originally this class had a digital training, which actually you can still take today for free. It's a little different than the classroom training, which has evolved, but it's still very valuable if you also want to review that as well. But Zachary, like this would be a great kind of resource to go through and like, do you have, understanding of executive insights, the business principles and whatnot? You may already, so I'm not assuming any of that. And then as you keep going, you can actually dive deeper into the Cloud Economics Center, how pricing works, all that stuff, right? Including the Cloud Adoption Framework. And if you want to keep going, notice that all of this leads up to taking the Cloud Practitioner exam. So doing these little digital trainings about machine learning and foundations, this is probably the best thing I can recommend for anybody who wants to get deep, like, and broad context, not deep, broad context on AWS. Because this is all not just the business modeling, but it's also things about how pricing works, how cloud adoption works, different things on compute services, storage services, database offerings. It goes deeper, actually, than the things that we've covered here, because this is just a one-day class. As you can see, this is probably somewhere between 10 and 20 hours of extra training, possibly more. But once you're finished with these extra little pieces, you are pretty close to ready to take the exam. And when I say pretty close to ready, there's usually one other thing I recommend, and I'm going to post the ramp up guides in here for all of you. This last thing that I typically recommend is that I usually recommend that you get some legitimate, legal, great practice exams. And so I'm going to post this here, but these are the ones that we've used with Booz Allen Hamilton, AWS. I mean, like I train people at AWS how to pass the exams. And we use these ramp up guides that the exam questions I just posted. That's the only thing that's missing from this, because these practice exams that they have are not great. They're just not great. And so I do recommend that you use someone like John Bonso, who creates these kind of courses. And in this course, what happens is you get a number of practice tests. And here's the cool thing. If you go in here and let's say we just look at the questions where I failed, right, which is for the whole thing because I just was quickly. John will not only give you the right answer, he'll tell you why the other answers are wrong, and he'll tell you exactly where he got the answers from, and he'll give you a cheat sheet if you need to study RDS. So like right here, he'll say, hey, this is incorrect. Here's why. This is incorrect. This is why. This is incorrect. So he'll tell you why the other answers are wrong. This kind of practice test that challenges and reinforces your knowledge and forces you to think holistically and recall information is one of the best ways to practice for the Cloud Practitioner certification. So my recommendation, Zachary, just for anybody who wants to continue down this road and get certification, but also for you specifically, just from a business professional standpoint, like increasing your breadth of knowledge and whatnot, I would come through and do all of the digital trainings that are listed here. And frankly, most people do not do this. Like even the people I know, like I have friends who are senior DevOps engineers, and they can't answer some of these questions that are presented in here because they just get like focused on their thing and they don't really understand holistically how AWS functions. So, I would say going through here and you'll probably be better than 80% of most cloud people that I encounter, right? So this is a great step-by-step guide. Note that every one of them ends with like access to learning resources. So if you want hands-on tutorials, you want a solutions library, you want the YouTube channel, you can always find it here. And that was just the business one. If we go back and look at, for example, I'm going to pick on developer for a second. If we go look at the developer guide is probably 3 times as long as the business guide, but doesn't include all the business relevant stuff. It has some of it, right? But immediately it deep dives into things like learning developer cloud fundamentals, how to, and it has the Cloud Practitioner exam, right? A little different. Then you start learning about containers. Then you start learning about the container services, the Kubernetes services. Then you start learning about serverless. Then you start busting through a whole bunch of serverless items that are completely like hardcore. And then you learn how to manage infrastructure as code, because that's a big piece of it as well. And then you learn about mobile and then some of the developer tools. And then and only then are you ready to take the associate's exam, right? Now, that's just the first level. After this is everything you need to know to pass the professional exam and all of the resources you need to do that. So just know that while it's a shorter path, it's deeper. And if you do the, like, it's basically weeks and weeks of training here, like probably 2 weeks, honestly. It's That's how the professional is achieved, right? I actually just re-upped on my professional DevOps engineer certification. And I did every single thing in here. And I got to tell you, it was amazing. Like I cannot tell you enough how much better I am from having, and I've been doing Amazon for 11 years, teaching since 2016, so 5, right? I can't tell you how much better some of this made me to go through these pieces, and I'm a veteran. So just to throw this out there, these guides are spectacular. Now, you'll laugh at this. I co-wrote some of this with Amazon. So you would think that if I wrote it, that I would actually would have done it, and it took me a while to get there. So Zachary, to your question, yeah, that would probably be the next best step is download the business guide. You could go for Cloud Practitioner. The guides, I don't remember the difference between the guides. There's just too much information. I think the business one and the other one contain a lot of the same things, but the Cloud Practitioner one is a little bit more hands-on. So you could actually go either way, actually. I would probably recommend the business one for a broader context. I would recommend the Cloud Practitioner if you want deeper technical context.
Thank you so much. That's perfect.
Yeah, good. Yeah, I love these guides. I love that we co-wrote them, and they keep putting out new ones. By the way, I'm just going to apologize. The only one I've been on this about this for a long time is that they haven't published a networking one. And if you remember, there is actually a networking specialty certification. There is not a single networking guide here, and I don't know why. And I've asked them to fix it, and they're working on it. So, okay, all right. So last thing, because if I don't do this, I will get in big trouble. So I get this last little piece. Let me see if I can pull it up. Give me just 1 second. Okay, because particularly with Booz Allen Hamilton, your feedback is incredibly important. I am going to post an evaluation link, and because that's the last thing I have. I have nothing else I need to talk about. Here's the evaluation link for the daily evaluation for the Cloud Practitioners Essentials. Otherwise, if you need to catch up with me, you can respond to my email. If you need me for anything else, you can actually catch me at WebAge Solutions, Michael.Forrester@WebAgeSolutions.com. Otherwise, I am open for questions, and we are done. So you don't have to stay here with me and hang out, but this is the official close of class. It's been a great pleasure to share this class with you today. And if you need anything, please let me know. Otherwise, we're done. Thanks, everyone.
Yeah, thanks, Michael. Great.